Most moons in our solar system look kinda similar, cold, gray, and covered in craters. But then there's Jupiter's natural satellite, Io, the angriest, most volcanically active moon in the entire solar system. It looks like a moldy pizza, smells like rotten eggs, and is currently exploding. While its neighbors are frozen and maybe hiding life, Io is blasting volcanic plumes 200 miles into space. Jupiter is truly giant. You could fit about 1,300 Earths inside it, so it sort of makes sense that it has more mass. More mass means more gravity, so much so that it basically makes Jupiter a moon magnet. It has 95 officially recognized moons, and most are tiny captured rocks, basically space rubble that got trapped. However, only 4 of them stand out as Jupiter's VIPs, with Io being the one that orbits closest. It's a bit larger than our moon, but the vibe is the opposite. Our moon is dusty and quiet. Io looks like a toxic chemical spill, and here's why. Io is caught in a gravity trap. Jupiter yanks on it from one side, and its neighbor moons impact it too. For every 4 orbits Io makes, Europa makes 2, and Ganymede makes 1. That timing keeps Io's orbit slightly off, so the squeezing never stops. This creates tides, but not ocean tides, rock tides. On Io, the solid ground bulges up and down by as much as 330 feet every single orbit. And since Io flies around Jupiter every 42 hours, it's a never-ending cycle. All that bending creates friction deep inside. It's like bending a paperclip back and forth. Do it fast enough and the metal gets warm. Except here, it gets hot enough to melt rock into magma. And that heat has to escape, so the pressure punches through the crust in hundreds of places. Some estimates put Io at around 400 volcanoes, and they don't all behave the same. Sometimes lava crawls across the ground. Other times, Io goes full cannon and blasts an eruption cloud of gas and dust hundreds of miles in the air. Imagine if an erupting volcano on Earth could reach all the way up to the International Space Station. This can happen because Io has lower gravity and a super thin atmosphere, so there's not much to slow the blast down. Plus, in near vacuum, hot gases expand fast and shove dust and volcanic material outward in huge arcs you could spot from far away. Non-stop eruptions are also why the moon looks like a giant marble dipped in mixed paint. Sulfur frost falls like dirty snow and stains the surface yellow, red, and black. Io is also famous for its lava lakes, and the biggest celebrity is Loki Patera, a volcanic bowl of about 126 miles across. What makes it cool is how it keeps refreshing its surface. A dark crust forms, then cracks and sinks. That can trigger a wave of fresh lava that rolls across the lake like a reset button. That's why Io has no craters from previous impacts like our moon or Mars. You'd expect the volcanoes to be mountains like Fuji or Etna. On Io, a lot of them are more like giant flat pits. The real mountains look like jagged slabs, like broken glass sticking out of the ground. The biggest one, South Bosal Mons, rises about 11 miles. That's like 2 Mount Everests on top of each other. These mountains don't grow like they do on Earth. Here, mountains don't usually build slowly because tectonic plates shove together, and the crust wrinkles up like a rug. On Io, it's like repaving the same street again and again. Eventually, the buried layers crack and huge slabs pop up sideways into jagged mountains, kind of like floor tiles snapping and popping upright. So where is all this lava coming from? For a long time, people thought Io had a global magma ocean right under the crust, basically a planet-sized water balloon, but filled with lava. Jupiter and other moons squeeze that balloon a bit and lava comes out. But according to the latest findings from NASA's Juno spacecraft that orbits Jupiter, that's not what's happening. On close flybys, Juno feels Io's gravity tug and uses that to measure how much the moon squishes. And Io doesn't squish like it has a shallow global lava ocean. The latest gravity measurements suggest the inside is mostly solid rock, but with lots of separate pockets of melted rock. It's not a balloon, it's more like a kitchen sponge, but instead of water, it has magma in different spots. That explains why the volcanoes are so chaotic. They're not all pulling from one global lava ocean. Many are likely fed by their own local magma chambers, so eruptions can pop off in different places, in different ways. All that chaos doesn't stay on Io. The colorful moon constantly leaks sulfur gases into space, and Jupiter's magnetic field scoops a lot of it up and spreads it into a glowing donut around the planet, right along Io's orbit. Scientists call it the Io plasma torus, and Io keeps refilling it at a rate of around 1 ton of material every second, like a moon-sized smoke machine that never turns off. But there's more. Io isn't just a volcano moon. It's like a giant space battery. As it races through Jupiter's enormous magnetic field, electricity builds up across it, the same way static builds up before a shock. That charge reaches around 400,000 volts, the kind of power used to move electricity across entire countries. And it drives an electric current of about 3 million amps. For scale, that current is like hundreds of thousands of home circuits running at once. That electricity doesn't stay on Io. It shoots along Jupiter's magnetic field lines in an invisible tube straight down into Jupiter's atmosphere. And where it hits, Jupiter lights up with a bright aurora spot called Io's footprint, like Io is dragging a glowing cursor across the planet. And as if the volcanoes and the lightning leash weren't enough, Io has one more trick. It loses its atmosphere once a day. Every time Io slips into Jupiter's shadow, the sunlight cuts off and the surface temperature drops. It gets so cold that the atmosphere literally freezes solid and falls to the ground as sulfur snow. For a couple of hours, the atmosphere deflates like a popped balloon. Then, Io comes back into sunlight, the frost warms up, turns back into gas, and the atmosphere refills again. It's like the moon is holding its breath behind Jupiter, then gasping back to life when the lights come on. And it's the same sulfur chemistry that paints the surface, so the moon is literally frosting and repainting itself as it goes. Studying Io is like watching a cosmic physics experiment run in real time. Juno taught us that tidal heating is messy. We used to think gravity melted a moon evenly to create a smooth layer of liquid inside. Io proves that wrong. The new data shows the interior is a sponge. Gravity melts specific pockets of rock, leaving the rest solid. This changes how we think about life on Europa and Enceladus, the icy moons that likely hide oceans under their ice. People get excited because heat from the rocky interior could power hydrothermal vents, and vents are like underwater chargers for life. But Io suggests that tidal heating might not warm the inside evenly. It might create scattered hot pockets, like a sponge with random warm spots instead of one steady heater. If that's true, vents on the seafloor might be rare and clustered. Life would not be spread across the whole ocean. It would gather around a few hot oases in a huge, dark, freezing sea. Io could also be like a mirror of Earth's past. Its lava temperature is closer to the superhot lavas our planet likely had billions of years ago. On Earth, the surface gets recycled and overwritten, especially on the ocean floor, so the oldest footage is missing or scrambled. But by watching Io, we can get a rare real-time glimpse of the kind of superhot volcanism Earth may have gone through early on, before the planet cooled down and long before life began. Io is incredibly fascinating. It's a world where the ground breathes fire, mountains snap up like broken tiles, and Jupiter literally plugs into an aurora. If this is what one little moon can do, just imagine what else is out there in the deep, dark space. Spotted. It seems like two giant stars were caught in the middle of a romantic kiss. This sounds a little bit like paparazzi fodder at first, but we're actually talking about a cosmic twist an international team of astronomers has discovered. So, the life cycle of a solar star is relatively simple. They're born in vast, gassy areas of space, burn through their fuel, and at some moment, they explode as supernovae. But when stars are born relatively close to each other, their gravitational pull can cause them some troubles and captivate them into what seems like an eternal dance. In some moments, they come so close to each other that they're practically touching. These stars may spend billions of years circling each other, but their kiss lasts for a few million years only, which is just a blink of an eye in cosmic terms. The lead author of this study was on a mission to find these binary stars caught in such a cosmic kiss. He focused his search on the Tarantula Nebula, a beautiful star-forming region located in the Large Magellanic Cloud, which is 160,000 light-years away from our home planet. And there it was, the shiny double star system that stood out from the rest. The two stars found there were pretty big and nearly the same size. Together, they make a mass of about 57 times larger than that of our Sun. Before this, we discovered only 3 other binary systems with a large mass. And since these two stars were so close to each other, they created an intense gravitational pull. This made them orbit each other at a staggering rate of once a day, with their centers a mere 7.4 miles apart. With the stars being so close, they formed a bridge where their fuel could mingle, allowing for around 30% of their total volume to be shared between the two. Temperatures of this system were crazy too. At first, it seems the internal mixing of their energy might make these stars live longer, as it allows for more fuel to be burned and for longer periods of time. But this is just a temporary benefit. There are 2 most likely scenarios for the star's ultimate fate. They could merge to form one giant star, which would eventually explode into a supernova. Or they could each explode separately and live out their remaining years as black holes orbiting each other. If they merge, this process would probably take around 600,000 years, while if they become binary black holes, they could continue burning for another 3 million years. But both scenarios would ultimately lead to their destruction. Unless the stars could end up as 2 separate black holes drifting away from each other through the vastness of space, there's a possibility for that to happen too. There's something spectacular stargazers across the globe could see recently. Jupiter and Venus, the 2 brightest planets in the sky, ended up so close it appeared like they were about to collide, or as if they were kissing too. At least that's what it looked like from here on Earth. In real terms, they're still 400 million miles away from each other. Here's another interesting thing astronomers like to talk about: G-objects. Those are celestial objects that look like clouds of dust and gas, but behave like stars. At the center of our galaxy, there's a supermassive black hole. It's 4 million times the mass of our Sun, and recently, scientists found out there are 2 mysterious G-objects that hang out pretty close to that black hole, so-called G1 and G2. And the most probable theory is that G2 are 2 stars that were orbiting the black hole in tandem and merged into an extremely large star cloaked in unusually thick gas and dust. During G2's closest approach to the black hole, it showed a strange signature. It was elongated, and much of its gas was torn apart. As it got closer to the black hole, it lost its outer shell, and now it's getting more compact again. The thing that has everyone excited about the G-objects is the material that gets pulled off of them by tidal forces as they sweep by the central black hole. This material must inevitably fall into the black hole, and the result is an impressive fireworks show. This happens because the material eaten by the black hole will heat up and emit radiation before it disappears across the event horizon. An event horizon is that scary boundary around a black hole from which nothing can escape. Now, it seems scientists have discovered 4 more G-objects, and they're all located within 0.13 light-years of this black hole. And it could be that all of the 6 objects used to be binary stars that got together and merged because of the powerful gravity of this giant black hole. Usually, it takes over 1 million years to finish the merging process between 2 stars. We definitely want more G objects because it's one of the rare opportunities for us to study how things behave near a supermassive black hole without being swallowed, yet. Have you heard of variable stars? Look up at the sky. We often think of the stars as unchanging, eternal lights. Yes, some stars might appear constant, but others change in brightness over time, which is why we call them variable stars. Some of them dim and brighten again over days, months, or even years. We can't see it with the naked eye. We're talking about changes astronomers can only notice using equipment and over longer periods. And how about vampire stars? Imagine 2 stars, a red giant and a white dwarf, in a binary system, swirling around each other like cosmic ballet dancers. The red giant, which used to be a vibrant and fiery star, now has aged and grown tired. Its outer layers of hydrogen, which were once held tightly by its gravity, have now weakened, making it vulnerable to the smaller, denser white dwarf. The white dwarf, known as the vampire star, thirsts for the hydrogen fuel that its larger sibling holds, and it sees a great chance there. As they spin together, the vampire star uses its powerful gravitational force to steal the hydrogen from the red giant's outer layers. The vampire star glows with a blue hue, looking full of energy and more youthful and vibrant than its aged dancing partner. Not only vampire stars, the horror continues with zombie stars too. Sometimes when the red giant explodes, it doesn't completely break up into smaller pieces. Instead, a white dwarf remnant is left behind. It's basically a zombie star that was gone at the moment, but has risen back to life. But this isn't your average zombie, hungry for brains. No, this star hungers for the very substance that its vampire sibling had been taking from it all along, hydrogen. And if the zombie star is close enough to its victim, it will start sucking material back in to start its core again. It will become a hydrogen explosive, ready to go boom in a spectacular show of cosmic revenge. It's a fascinating phenomenon. We usually won't even manage to detect it because these explosions are much fainter than the usual supernovas. But when it does happen, the resulting blast is truly epic. And it destroys both the vampire star and its zombie sibling. It seems vampires and zombies may not be a work of fiction after all. Not only are we made of stardust, but we're also more similar to stars than we thought too. For example, stars also like to hang out with their close group of friends. Most stars prefer to travel through the universe in clusters. It's a group of stars that end up bound together by gravitational force. The stars in the cluster are mostly made of the same age and type, hobbies and interests. I guess even they have better social lives than I do.
When you look at the night sky, it seems like there's not much happening up there, and that the stars always twinkle at the same spot. For thousands of years, researchers followed the idea that the lights in the sky were unchanging. Sailors guided their ships using fixed stellar patterns. There are also the exact outlines of constellations we observe today, and astronomers identified them a long time ago. It seems impossible that one day we wake up and simply can't see some stars anymore. Or does it? A team of researchers at Vanishing and Appearing Sources During a Century of Observations, or VASCO, studied the sky to check how things with the stars are going. The astronomers got the data from Gaia, the European Space Agency, and compared the information from 70 years ago to that from today to see how the sky has changed. To test it right, they had to use both modern and old telescopes. And something really interesting happened up there. Over 700 stars from the old maps were missing. If one star disappears, multiple theories could work. but it's harder when hundreds of them vanished at the same time. Could it be that the data was wrong, or these stars were too faint to detect? Nope, they quickly eliminated this option because these stars had clearly been part of their earlier observations. So, the first thing that comes to mind when talking about how stars disappear is that they reached the point where they ended their lives. You can have the most massive stars of all, and we're talking about those that are way heavier than our sun, and they go through sudden changes as they get to the end, which we also call a supernova. It's a powerful explosion that later shines for many, many months, and it's still visible even across hundreds of millions of light years. But that's the point. You see the traces, unlike here. Could this be a failed supernova? That means maybe one of them collapsed but turned into a black hole and consumed the remains from the inside out without causing a powerful explosion. But no one's been mentioning any signs of a black hole being active anywhere near those stars. And what if the stars had become less visible because of dust or gas around them? This is something that can easily happen, as interstellar dust and gas do block our view of objects that are far away. But there were no traces of unusually high concentrations of dust or gas. Nothing destroyed them either. Researchers would have seen traces if something like that had happened. Plus, these missing stars were not all in the same area, which means there probably wasn't just one fatal thing that made them all disappear. Also, the stars were not at the same stage of their life, so it's not an option they were all accidentally close to their end. They weren't particularly old or young, and they were on different levels in size and brightness. At some moments, it even seemed these stars haven't vanished because of some natural events. Maybe it was something related to other civilizations that might be somewhere out there in space. Maybe that's one of the ways to look for them. We could stumble upon some secret civilizations from other planets if we carefully observed the behaviors of stars, especially those we can't explain. No one knows what exactly happened with the missing stars, and unfortunately, right now, all we have are these theories. But you have to admit, they're cool though. Maybe it's just some kind of optical afterglow caused by gamma-ray bursts, or maybe even fast radio bursts. Fast radio bursts are powerful pulses of radio waves. They can release more energy in a couple of thousandths of a second than our giant sun does in almost 100 years. We don't really understand how these energy eruptions work yet, so we don't know what they can do. But still, hundreds of stars at approximately the same time. There are between 100 to 400 billion stars in our galaxy, so we'll probably see some of them disappear too. Hopefully, we'll understand better why such things can happen. Of course, scientists are not sure about this number because we can't see all of the Milky Way stars from our home planet. Some are too faint, some are too far, or even hidden by dust or gas. But they assume these numbers based on the size, shape, and likely mass of the Milky Way. And out of billions of stars, there are a little over 9,000 of them we can see with the naked eye. If you want to see more, you need a good telescope that will reveal those fainter ones your eyes are unable to discern. Many of the stars we see in the night sky are probably not alive anymore. Stars are giant balls of gas that produce light and heat through nuclear fusion in their cores. However, stars also have a limited lifespan, and eventually, they run out of fuel and stop shining. When a star passes, it can either become a white dwarf, neutron star, or black hole, depending on its size. Scientists have discovered that some of the stars we see in the night sky are too old to still be shining. This means that they may have faded, but we are still seeing their light because it takes so long to reach us. Actually, we may be looking at the past when we look up at the stars. Check out all of the stars you can see with your bare eyes. They lie within about 4,000 light years of us. That means what we're seeing are stars that appeared 4,000 years ago. Most of the stars we know of exist within galaxies, which are massive collections of stars, gas, and dust held together by gravity. Still, there are large areas of empty space between galaxies too, And the question is, could they have any stars? It seems that these areas of space are not completely empty. There is still some gas and dust, as well as dark matter, which is a type of matter that we cannot see but we know exists because of its gravitational effects on other objects. Scientists have even discovered a few isolated stars in these areas of space. These stars didn't form there. They ended up there by accident, which means they have probably been ejected from their galaxies by gravitational forces or collisions with other objects. And there could be more of these stars than we realize, but they are simply too dim to be seen from Earth. Stars don't actually twinkle. It's more that we just see it like that from the Earth. It seems like they twinkle because of the turbulent atmosphere of our planet. The light from a star must pass through many layers of the atmosphere. Not every layer is equally dense, so this causes the light to slightly deflect and change in color and intensity. There's one star named Sirius that sometimes twinkles, sparkles, and flashes so much that some people even tend to report it as something extraterrestrial. This is because Sirius is very bright and is often low on the horizon, which means it experiences more of these special effects of the Earth's atmosphere. When in space, astronomers and astronauts who observe stars from there don't see them twinkling. Hey, want to hear something cool? Me, you, your friends, the rest of humanity, we're all made of stardust. The elements that make up human bodies and all life on Earth were formed inside stars. The building blocks of life, such as carbon, nitrogen, and oxygen, were created inside stars and were eventually released into space when the stars were gone. These elements then became part of new stars, planets, and eventually life on Earth. The iron in our blood was created in the cores of supernovas, which are massive explosions that occur when stars fade. Some say that even the calcium in our teeth and bones is likely to come from exploding stars. The oxygen in our lungs was created in the cores of massive stars before being released into space through supernovas. Imagine leaving your house one morning and seeing not one, but two stars shining in the sky. The first one is our good old sun, and the other is Jupiter. But how has a planet turned into a star? And what will now happen to Earth and its inhabitants? Before we find the answer to these urgent questions, we need to revise some things we know about Jupiter. The largest planet in the solar system is a gas giant, which means it's made up mostly of gases. Due to the pressure and temperature differences, these gases separate into layers. This creates those red and white bands that can be clearly seen from Earth. The temperatures at the top of Jupiter's atmosphere are insane. They can reach a whopping 1,340 degrees Fahrenheit. The planet also has an immense gravitational pull. In 1995, the Galileo probe reached the atmosphere of Jupiter and sliced it at a speed of 106,000 miles per hour. It survived the scorching temperatures and started its descent. It kept moving even when the temperatures suddenly dropped and the pressure, as well as the speed of the wind, increased. But 58 minutes and 97 miles into its exploration, things went downhill. The pressure of 23 atmospheres and still high temperatures finished the probe off. It was melted and then vaporized by the extreme heat. Now, if Jupiter suddenly decided to keep growing, it would eventually become a star, and its composition would allow this planet to do it. Once, a long, long time ago, Jupiter took most of the mass that was left after the formation of our Sun. That's how it ended up with more than twice the combined material of all other bodies in the solar system. And the planet's ingredients are the same as those of a star, mostly hydrogen and helium. Jupiter is just not massive enough to ignite. But what if it was? Then it would turn into another kind of celestial body, most likely a brown dwarf. In this case, it would have a minor effect on the orbits of the planets of our solar system, because brown dwarfs are more massive than planets, but not as massive as stars. A brown dwarf is usually 13 to 80 times the mass of Jupiter. It can only become a star if the pressure in its core gets high enough to start nuclear fusion. So let's imagine that it's happened, and Jupiter has become a real star. For example, a red dwarf. Red dwarfs are stars with masses around 7.5% to 50% of the mass of our Sun. Red dwarfs are also hotter than brown dwarfs. Their temperature can reach 6,380 degrees Fahrenheit. Our Sun, by comparison, has a temperature of almost 10,000 degrees Fahrenheit. So, it means that the newly formed red dwarf will be far dimmer than the Sun. And still, red dwarf Jupiter could prevent the inner planets from following their orbits, because they wouldn't be able to find a balance between the gravitational forces of the two stars. The planets would move either closer to the Sun or closer to the newly formed red dwarf. If Earth chose the first option, our main star's insane temperatures would probably wipe all living beings off the face of the Earth in no time. If it was the second scenario, we'd probably freeze, since Jupiter, as a dim red dwarf, wouldn't be able to warm us up well enough. But there could be one more option. The inner planets could get thrown out of the solar system altogether. If Jupiter was a star, it would also greatly increase the amount of radiation the surface of Earth would receive. Our atmosphere would have to protect us both from the radiation coming from the Sun and from Jupiter's radiation. Red dwarfs are notoriously active. That's why Jupiter, just like the Sun, would most likely have frequent coronal mass ejections. This is a fancy expression for describing large clouds of electrically charged particles a star releases with a huge burst of speed. Even now, Jupiter has a significant impact on our planet. The gas giant is roughly 318 times as massive as Earth. And this also means it has an outsized pull on our planet. Its gravity can cause shifts in the orbit of our planet and climate swings every 400,000 years or so. When Jupiter's influence is the strongest, Earth usually has colder winters, hotter summers, and more intense periods of wetness and droughts. Also, if Jupiter turned into a red dwarf, its most prominent feature might probably disappear for good. I'm talking about the Great Red Spot. It's an enormous storm raging in the southern hemisphere of the gas giant. Its top parts tower more than 5 miles above the tops of the surrounding clouds. The storm is almost twice as wide as our planet. In 2017, NASA's Juno space probe managed to collect lots of data about the red spot, and it turned out that this monster of a storm went more than 200 miles down into the planet's atmosphere. That's 30 to 100 times deeper than any ocean on Earth. But these measurements are most likely imprecise, and the storm's true roots can be reaching even deeper. The Great Red Spot is colder than the rest of the atmosphere, and keep in mind that Jupiter's temperatures are negative 280 degrees Fahrenheit in the upper cloud layers. On the other hand, the closer to the core, the hotter it gets. Mysteriously, the highest temperatures ever recorded on the gas giant occurred in the atmosphere right above the Great Red Spot. They were higher than the temperature of lava on our planet. Astronomers believe that the turbulence caused by the storm might produce gravitational and sound waves that can be responsible for the superheating. But the storm itself is warmer at the bottom than at the top. People have been watching the moving vortex on Jupiter for more than 150 years. Some time ago, astronomers predicted that it would gradually slow down and become smaller or disappear altogether. But that turned out not to be the case. After having analyzed all the data received with the help of the Hubble Space Telescope, researchers were baffled to discover that the winds at the outer boundaries of the storm had actually picked up speed. The wind speed at the edges of the storm can reach a mind-boggling 400 miles per hour. That's faster than Earth's tornadoes. At the same time, if you found yourself at the center of the Great Red Spot, you wouldn't be too impressed. The winds there move way more slowly. And now, I have another what-if situation for you. What if Jupiter collided with the smallest star we know about? Today, these two space bodies are on a collision course. A spoiler, Earth might not survive such an encounter. Okay, meet this tiny red dwarf. It's the size of Saturn, and its gravity is around 300 times the gravity of our planet. It normally floats 600 light-years away from Earth in a double-star system. But today, for some inexplicable reason, it's broken all the laws of the universe and is rushing toward the biggest gas giant in our solar system. And even though this space guest is smaller than Jupiter, its mass is way greater, and its gravitational force soon starts to pull on the gas giant. The heat from the red dwarf, plus its powerful gravity, makes Jupiter grow in size. The planet's atmosphere starts to puff up because the gases that make up the planet begin to heat up and expand. Jupiter's atmosphere starts to leak into space toward the stellar visitor. Sometime later, the runaway gases form a bright hot ring around the red dwarf. This is a terrifying view, as if a black hole, a very bright one, has appeared inside the solar system. The star keeps tearing Jupiter apart, eating chunks of the gas giant, and soon the red dwarf engulfs it completely. Sadly, Jupiter never stood a chance. Instead of the gas giant, we now have a red dwarf surrounded by a ring of hot gases. And we already know how badly it may end. The best thing about it is that this scenario is totally imaginary. Phew, thank goodness.
Imagine a being so powerful it can suck in entire galaxies, so mysterious it's invisible to the naked eye, and so impressive it bends the very fabric of space and time to its will. Yes, meet my mother. Just kidding. Actually, meet the ultimate superhero of the universe, the black hole star. What is it and how does it work? Well, let's find out. The universe is full of marvels, and the black hole star is one of the most impressive ones. It's a supermassive force that can bend the laws of physics, and a true enigma for scientists to unravel. No wonder science fiction writers find them so captivating. A black hole star, also known as a quasi-star, is a hypothetical type of extremely massive and luminous star that may have existed early in the history of the galaxy. They're predicted to be as luminous as a small galaxy, but unlike modern stars, they weren't powered by nuclear fusion in their cores. A quasi-star's energy would come from material falling into a black hole at its core. And yes, just like a normal black hole, these stars have the power to suck in anything and everything that gets too close, including stars, dust, and even entire galaxies. But how is it possible that the star is born from a black hole? And what's more, how do they continue to coexist together? Well, first let's discuss how black holes are born in general. It all starts with a supermassive star, one that is at least a few times more massive than our own sun. This giant of a star burns bright and hot, shining with the light of 1,000,000 suns. But eventually, it runs out of fuel and its fate is sealed. As its lifespan comes to an end, it makes one final massive boom, a blast so powerful it can outshine an entire galaxy. This blast is called supernova. During this boom, the outer layers of the star fly away, while the core gets squished together by its own gravity. If the squished core is heavy enough, it can keep squishing until it becomes a black hole. And just like that, a black hole is born. Don't even try to put diapers on this thing. Now, this cosmic monster baby can continue to grow by swallowing up anything that comes too close, including stars, dust, and even entire galaxies. This is basically what's happening now in our universe with supermassive stars. But what about quasi-stars? The formation of a quasi-star could only happen early in the development of the universe, before hydrogen and helium were contaminated by heavier elements. And because of that, quasi-stars have one important feature. They are gigantic, so enormous that it's literally impossible to imagine. They may have been dwarfing even the largest known modern stars, like VY Canis Majoris and Stephenson 218. No wonder they're so scary. They were born from protostars, one of the first stars in the universe, the great-great-grandfathers of, everything. So now, imagine a protostar so massive that its core collapses into a black hole, just like we described before. But the key difference is that in a regular supernova, the outer layers of the star are blown away by the energy released during the boom. Meanwhile, in a quasi-star, These outer layers are massive enough to absorb the energy without being blown away. What do we get in the end? A star with a black hole in its core that weighs from 1,000 to 10,000 solar masses. This quasi-star is about 14,000 times bigger than our Sun, which makes them bigger than any star we know today. These celestial titans have some pretty crazy properties. Once a black hole is formed at the center of a giant protostar, it starts to give off a ton of energy. This energy helps to balance out the force of gravity, making it kind of a giant fusion-based star. They would be so bright that each one would look like a small galaxy. Quasi-stars would have a pretty short lifespan, around 7 million years. Just for comparison, our Sun is about 4.5 billion years old, and it's only halfway through its lifetime. But either way, during this short period, the black hole at the center would grow to be about 1,000 to 10,000 times the size of our Sun. Quasi-stars are also thought to be super hot, with temperatures reaching over 17,500 degrees. But as a quasi-star gets older, it starts to cool down, and its outer layers become see-through. Eventually, it cools down to a temperature of 6,740 degrees, and at that point, it's curtains for the quasi-star. It can't survive at that temperature, so it just dissipates, leaving behind an intermediate mass black hole. Unfortunately, right now, there's no observational evidence for the existence of quasi-stars. This is because they're thought to have only existed a very, very long time ago. They may have been very massive population 3 stars, which are extremely rare and difficult to detect. It's also very unlikely that any of them would still exist today because of their super short lifespan, only 7 million years. So why do scientists believe that quasi-stars could have existed? Because they're looking for ways to explain how supermassive black holes formed so early in the history of the universe. They're found at the center of most galaxies. But how could these monsters have formed so quickly? After all, it takes a really long time for small black holes to grow into supermassive ones. This is where the idea of quasi-stars come in. These stars aren't just destructive forces of nature. They're like the black belts in the martial art of gravity. They can bend and twist anything to its will. That's why these stars, if they really existed, had to play a crucial role in the evolution of galaxies. They must have been instrumental in shaping the universe as we know it. So, those intermediate-sized black holes that they left behind could eventually turn into supermassive black holes in the center of galaxies. But we're still yet to solve this cosmic mystery. Detection and study of black hole stars is like trying to find a needle in a haystack. Only instead of a needle, it's an invisible and mysterious object. And instead of a haystack, it's the vast expanse of space. But with the help of some pretty cool technology and a lot of brainpower, scientists are getting closer to uncovering the secrets of these celestial giants. Here are some things that can help us in this research. First of all, gravitational waves. They're like ripples in the fabric of space-time, caused by the movement of massive objects. Albert Einstein predicted them way back in the 20th century, but they were finally detected only in 2015. We caught them by observing the collision of 2 black holes. This discovery confirmed that black holes can merge and that they're a powerful source of gravitational waves. Scientists think that by studying these waves, they can learn more about how black holes form and grow. We can also try to detect quasi-stars by observing the effects of their gravity on nearby objects. It's like trying to spot a criminal by their fingerprints. For example, if a black hole is located near a star, scientists can observe the star's light being distorted as it's pulled toward the black hole. And of course, we can use our technologies, such as X-ray, infrared, and radio telescopes. This allows us to study black holes in various ways and at different stages of their lives. In other words, scientists are working hard to uncover the secrets of these celestial giants. We develop new telescopes, search for primordial black holes, and try to understand the connection between black hole stars and dark matter. And we're making some pretty incredible discoveries, just like with gravitational waves. All these things will bring us closer to uncovering the secrets of quasi-stars. And when we find out the truth about them, it will become a new page in our scientific history.
A sound from space? When up there in space, no one can hear you talk, laugh, or scream. Or at least that's how the saying goes. People can't hear anything in space due to its condition. Still, if you have the right conditions, like the hot gas that surrounds the black hole located at the center of Perseus, space can be quite noisy. That's the galaxy cluster 250 million light-years away from us. Researchers caught an actual sound of space, waves rippling through the plasma gas in Perseus. They first realized black holes generate acoustic signals in 2003, but this is the first time they brought these signals to the human ear, and wow, this sounds terrifying. Canyons filled with liquid on Titan. Almost a decade ago, NASA spacecraft discovered deep canyons on one of Saturn's moons, Titan. They're about a half-mile wide and they kinda look like the Grand Canyon, but they're filled with liquid hydrocarbon. This was the first time we came upon evidence of canyons and channels filled with liquid on Titan. Our solar system is full of small particles and bigger rocks that circle the sun, the same way as planets. Sometimes it happens, some of them change trajectory, which is why falling pieces of debris strike the planets. Most of the meteorites and comets originate in our solar system. Some from the asteroid belt between Jupiter and Mars, while others come from the Kuiper belt, that's located beyond the orbit of Neptune. But 5 years ago, scientists found something unusual, a red, elongated floating space rock called Oumuamua. It could be more than 3,000 feet long, but its size still wasn't the most impressive part. It was the first interstellar object we saw passing through our solar system. It means it formed and came outside of it. It was traveling way faster than asteroids and comets from within our solar system. No one knows where this weird object came from. Many, many years ago, when it started its journey and sailed away from its parent planetary system, the stars weren't in the same position as they are today, so it's hard to pinpoint where Oumuamua ran away from. The rock could have been on its journey for billions of years. Solar termination events. Our sun is not just a flaming ball of gas we see in the sky. It's actually a pretty complex network of towering plasma fountains, magnetic fields, and blobs of unusual matter 500 times bigger than our own planet. And then there are solar termination events. When it comes to its activity, our sun goes through a natural cycle of troughs and peaks. Approximately every 11 years comes the time when the sun is more active than in other periods of the process. As the cycle goes to the end, there are fewer emissions and sunspots. That's because magnetic fields are weakened at that point, and they collide along the sun's equator. This results in enormous tsunamis of plasma. They pass across the solar surface for weeks. These are the most powerful storms in our solar system. They twist, snap, and lash out into space and seriously affect our power grid. As they wake, large spots start to form on the sun, close to strong magnetic field lines. Usually, that's when the cycle begins all over again. No one still knows why exactly they form. Also, we're not sure if this only happens at the end of the cycle, and knowing more about this could help us prepare for raging solar storms better. Tsunamis on Mars. It appears the shorelines under the Martian surface formed because of two enormous tsunamis. Mars has something that's probably the longest landslide in our entire solar system. The rocks rolled down the mountain probably billions of years ago. They fell into the water and caused a gigantic wave that rushed across the Martian landscape. As the tsunami was getting bigger, the rocks scraped all along the solid ground beneath them, and these sandy waves left their prints on the shoreline, not so close to Olympus Mons. That means it's possible the waves traveled a couple of hundred miles. This supports the theory that Mars once had an ocean hidden below its dry desert surface. Sure, Oumuamua was cool because it was the first object we've seen coming from outside of our solar system. It's past us now, so it's not possible to study it anymore. But something else came from outside our solar system after Oumuamua. a comet called Borisov. It came with a tail over 100,000 miles long. Teams got the first images of Borisov in 2019. A bright white glow was surrounding it. And that was one of the first signs where scientists realized this comet wasn't from our solar system. They tried to collect as much information as possible because they remembered how quickly Oumuamua got away. Borisov came from a freezing place as cold as the Kuiper Belt. One theory says it may have originated around a red dwarf, which is the most common type of star in our galaxy, the Milky Way. But unfortunately, Borisov was also very fast. So fast that they only managed to see it a couple of weeks before it passed by our planet. By now, it's almost out of our solar system. Finding new planets is always such a thrill, just like it was in 2017 when a group of researchers discovered Super-Earth. It's an exoplanet, which means it orbits a star outside of our solar system. This one has a mass almost 3 times that of our planet, and it's only 21 light-years away. It orbits M-dwarf star, and it manages to make a full circle in only 2 weeks. So that's how long the year is on this planet. It's closer to its star than Mercury is to our Sun. But M-dwarf stars are cooler than our Sun, so it's possible this planet still has water. Super-Earth is generally a term for planets that are lighter than ice giants such as Uranus and Neptune, yet more massive than Earth. They can be made of rock, gas, or even a combination of both. The one they discovered in 2017 is especially interesting because this type of planet can also hold some form of life. Leroy Chiao is an astronaut who commanded the International Space Station back in 2005. This one time, during his final spacewalk, some pretty unusual lights caught his eye. It looked like 5 lights flying near him. They were in the shape of a pyramid, since one light was a bit further ahead. Chiao immediately called one of the crew members who was also out there at the same time, taking a spacewalk. He asked his colleague if he saw the flying objects, but apparently he didn't. Researchers were intrigued by this story, so they examined satellite images to see if that was the thing Chiao saw. One of the options was that Chiao had seen fishing boats off the coast of South America. With bright lights, they wanted to attract squid. But since it was twilight time, the rotation of our planet may have made them appear to fly by. Neutron stars slamming into each other. After a massive star comes to its end in a strong supernova explosion, its core falls apart. Then it forms the densest form of matter we know about in the whole universe, called a neutron star. In only a couple of the first few seconds after a regular star begins transforming into a neutron star, the energy there is equal to the total amount of light all stars in the universe emit. At least the part we can observe, which is still a lot. It's hard to determine their real size, but picture it this way. The length of Manhattan with 1.5 times the mass of the Sun. If a star here were any denser, it would just collapse and form a black hole. Scientists captured 2 of these stars colliding a couple of years ago, and such impacts are extremely powerful. They create gravitational waves that lead to a ripple in space-time, but they produce heavy elements like platinum and gold. What would the Earth look like if it was born in another solar system? I did a little research for you to find out, and the results were surprisingly wholesome. There are some warm tropics, strong winds, and giant dragonflies. But okay, let me explain from the very beginning. Since 1995, NASA has discovered more than 4,100 planets outside the solar system. Unfortunately, most of them are either flying ice balls like Neptune or gas giants like Jupiter. But there are still as many as 161 planets similar to our Earth. And one of them is very close to us, in the Alpha Centauri constellation. There are 3 stars in this constellation. 2 of them are called Alpha Centauri A and Alpha Centauri B. If you live in the southern hemisphere, you've probably seen them. They're very bright. Because of that, they look like one big star. They rotate around each other very slowly. And there's the third star, chilling around not far from them. It's a teeny tiny red dwarf, Proxima Centauri. It got its name because of its proximity to our Sun. This star is the most interesting one, so let's talk more about it. Proxima Centauri is only 4.5 light-years away from us. Oh, and 1 light-year is about 6 trillion miles. Yep. If we went there, it would have taken just a little over 165,000 years of traveling in a space shuttle. Oh, you think that's a lot? For the universe, it's like checking on your fridge. Proxima Centauri is much lighter and much smaller than the Sun. It's also 2 times colder than the Sun, with a temperature of 3,000 Kelvin. That's why we can't see it without a telescope. On the bright side though, it will burn for trillions of years, and you don't have to worry that one day it will eat us like our Sun. And yes, our twin planet is located right next to Proxima Centauri. This planet is called Proxima b. Yeah, I know, they got creative with all these names. I hope you won't get confused. It's slightly larger and more massive than the Earth. This planet is located in the habitable zone of Proxima Centauri. It means that there can be water and even some microorganisms there. Yes, it's possible that one day we'll find some life there. But right now, we don't know much about this mysterious planet. It's probably a rocky planet like our Earth and has a similar landscape, but this is just a theory. Who knows what kind of jokes the universe can throw at us? It would be a shame to fly 165,000 years just to stumble upon a giant piece of ice or something. Fortunately, we probably don't have to wait that long. The big brains are now developing a technology that would allow us to move at the speed close to the speed of light. If they succeed, we'll get to Proxima b in just 20 years. But anyway, this video is not just about Proxima b. It's about what would have happened if life had originated not in our solar system, but in Alpha Centauri. What if we were orbiting Proxima Centauri, or the other 2 stars? So now, let's imagine that the Earth has replaced Proxima b. I'm going to call this new planet New Earth. Guess I'm not very creative at naming either. First of all, the orbit. The new Earth must be about 25 times closer to its star than Proxima b is. Otherwise, it would be unimaginably cold. Let's move the planet a little closer. Excellent. The day still lasts 24 hours, but our orbital period is very high. Proxima b revolves around its star in 11 days. But we'll make it in just 8. Hey, a birthday party every week? Sign me up. Oh, hold on, there's another problem. You see, Proxima Centauri is a flare star. This means that sometimes, just out of nowhere, it throws out some stellar winds. These winds carry around a bunch of ionized particles, which then settle on the planets. Yeah, our Sun also does that, but Proxima Centauri tries to finish us off 2,000 times harder than our Sun, so the radiation levels are off the scale, to say the least. Don't worry, it's fine. All we need are incredibly strong magnetic fields. They will help us create a very thick atmosphere that can protect us from the Proxima Centauri's tantrums. So now it's going to be very warm, or not. Another problem. Scientists are still not sure how exactly Proxima Centauri's planets rotate around it. What if they turn out to be tidally locked, like our moon? Then one half of the new Earth will be a frying pan, and the other half will be some frosty deserts. Oh, it's fine, we'll just settle down somewhere in the middle. Didn't expect that I would ever say this, but it will definitely be warm at the North Pole. And if we're lucky with the rotation, we'll just get a cozy, warm planet. The average temperature is about 70 degrees Fahrenheit, and there aren't any extreme temperatures. On the new Earth, we have much more water. The weather is generally pretty crazy, some very strong winds and quite destructive rains that can go on for quite a long time, but you can adapt. Temperature changes are much more noticeable in the mountains. Just like on Earth, the higher you climb, the colder it gets, except it's very cold right here at the top. Because of this, the mountains and hills have jungles below and snow-covered deserts on the tops. but in general, it's almost like the Earth's tropics. The flora is very rich, the trees are very low but lush. The thick atmosphere also makes flying easier, so there are a lot of large flying animals, like dragonflies with a wingspan of 16 feet. Moving on. The sky here is much lighter than that on Earth and very cloudy. Sometimes it may seem completely white. But the starry night is beautiful and bright. There are 4 suns. Our main one is Proxima Centauri. We can also see 2 bright Alpha Centauri stars. And finally, our old sun, which looks like a bright, distant star. I'll allow you to shed a tear for the old Earth. There's a few planets near us, like Proxima Centauri c. The host star is surrounded by 2 belts of cosmic dust, so get ready for some gorgeous, colorful night views. So what we have in the end is a little crazy, but a beautiful green planet. I personally wouldn't mind moving there already. What about you? Write in the comments. Alright, so now we know what would have happened if our Earth had been born near Proxima Centauri. What about the other 2 stars? Unfortunately, we won't be able to rotate near 2 stars at the same time. Scientists suspect that Alpha Centauri A and B have some kind of common planet that jumps from one orbit to another, but it's probably very cold. Let's choose Alpha Centauri A. Just like on the new Earth, here our average temperatures are about 70 degrees Fahrenheit, but now the temperature variation is quite large. It goes from negative 100 degrees Fahrenheit at the South Pole to 113 degrees Fahrenheit at the equator. We'll be fine close to the north. The day is still 24 hours, and the orbital period is 1 year and 1 month. It's almost the same for the Alpha Centauri B, but the orbital period is about half a year. Other conditions are very similar to those on Earth. Changes in the seasons are almost not noticeable. The temperatures don't change much either. No matter where we settle down, the neighboring star will be clearly visible, but we probably won't see Proxima Centauri. And that's about it. Of course, all this assumes perfect conditions. Just like on Earth, one slightest change, whether it's a thin atmosphere or a bigger distance from the star, and it won't end well. We got really lucky with our Earth. But even so, the chances of finding a habitable planet are very high. Even with the tiniest possibility, there will be about 15 million planets in our universe that we can find life on.
Castles were cold places in times past. The stone seemed to radiate the winter chill. This is one practical reason why tapestries were hung upon castle walls, to help keep the cold out and the warmth in. But you just can't hang any old thing on castle walls. It should be beautiful, heroic, with a heavy wow factor. The ancient Greeks hung tapestries on the walls of their castle of the sky, glorious tapestries woven of stars. All 48 constellations of the Northern Hemisphere were designed and named by the Greeks. The story of Andromeda is one such tapestry, woven of 7 constellations spread across the entire autumn sky. The story contains detailed astronomical observations preserved as highlights in the sky tapestry. It begins with the constellation Cassiopeia, queen of the oldest realm in Africa, Ethiopia. When the constellation Cassiopeia is on the horizon, it looks like a staircase going up to the Milky Way. Step pyramids around the world are often thought to have been inspired by the constellation Cassiopeia. In any case, Cassiopeia is a beautiful constellation, indicating that Queen Cassiopeia was also a beautiful woman. She was good-looking, but equally vain, which sets off all the dramatic action. Cassiopeia can be found in the night sky opposite Ursa Major from the North Star. Like Ursa Major, Cassiopeia circles the North Star and is a circumpolar constellation. A supernova was observed in Cassiopeia around 1680 Earth time. Cassiopeia A having occurred about 11,000 years earlier. The Chandra X-ray satellite recently recorded an extraordinary photograph of this supernova remnant showing the elements sulfur, calcium, silicon, and iron amid the expanding cloud's high-intensity X-rays. Cassiopeia's husband is also a circumpolar constellation, a minor, dim one named Cepheus. He had his own kingdom. A merger of empires by way of marriage is something common throughout history. Cepheus was a king of Phoenicia. There were many kings of Phoenicia back in the days when Phoenicia was just a collection of city-states along the western shore of the Mediterranean Sea. Cepheus can be found in the area between Cassiopeia and the North Star. The constellation of Cepheus is important to astronomers. It's where Henrietta Swan Leavitt discovered variable stars that pulsed at regular intervals. The rate of pulsation of the star indicates the true brightness of the star and enables a sure measurement of the distance to the star. The discovery of Cepheid variable stars was a major breakthrough for early 20th century astronomy. Cepheus and Cassiopeia had a daughter, Andromeda, also a noted beauty, about whom all the fuss is. It seems that one day Cassiopeia was boasting about the beauty of her and her daughter Andromeda. "We are more beautiful than any other women in the whole wide world." Well, such pretension can be forgiven for a queen. But then Cassiopeia went further and stepped beyond all natural bounds. In fact, "We are more beautiful than any of the Nereids." Well, the Nereids were Greek mythological sea nymphs, daughters of the ocean. Noted for their beauty and kindness to sailors, the Nereids, all 50 of them, took offense at being dissed by a mere mortal woman. Cassiopeia had to be punished for exceeding the bounds of the civil order. By her excessive vanity, Cassiopeia transgressed beyond the bounds of nature, for which an unnatural punishment was inflicted upon the entire kingdom of Ethiopia. A monster from the bottom of the ocean, the constellation Cetus, began to devastate the coastal villages of Ethiopia as well as Ethiopia's fishing ships. Fittingly, Cetus is a constellation of the southern celestial hemisphere. The fourth largest by area of all the constellations, Cetus swims in a dark part of the sky called the ocean, with only its head rising above the celestial equator. This part of the sky contains several water-themed constellations: Pisces, the fishes, Aquarius, the water-bearer, and Eridanus, the river. Over 50 exoplanets have been discovered in Cetus. You can bet the James Webb Space Telescope will have a field day analyzing the spectra of these planets' atmospheres, looking for signs of life. Meanwhile, Queen Cassiopeia and King Cepheus must do something about the monster devastating the shores of Ethiopia. They consult an oracle and make another trespass beyond the realm of reason and nature. "Tell us, oracle, what can we do to stop the monster from ravaging our kingdom?" This monster is not a normal affliction of nature. An offense was committed against the higher realms, and this is the punishment. The monster cannot be stopped by any normal means. Only a human sacrifice of the noblest being may placate the beast. One error compounds another. The noblest person in the kingdom, of course, is Princess Andromeda. According to the command of her father and the consent, or perhaps a suggestion of her mother, Andromeda is chained to a rock offshore. She is the human sacrifice that her parents hope will save the kingdom. Wow. Da-da-da-da! Here comes the Greek hero to save the day, stop the human sacrifice, and turn Cetus to stone. Perseus. Now, where is Perseus coming from? According to legend, the Hebrides. Perseus went to the Hebrides in pursuit of the Gorgon Medusa. The geological scope of this tapestry is incredible, from the Hebrides to the Red Sea. The Hebrides are an archipelago of mostly rocky islands off the western coast of Scotland. It was impossible to sail any further. The Hebrides were the absolute end of the world. Perseus didn't have to sail to the Hebrides. However, he flew on a pair of winged sandals. Hey, way to go, Perseus! Now, Medusa was one of the all-time baddies. One look at Medusa was so terrifying it would petrify you, literally turn you to stone. Perseus was in great danger. So, what did our hero do? Instead of looking at Medusa, Perseus used the scientific principle of reflection. He slew Medusa by seeing her reflected in his polished shield. In our sky tapestry, Perseus is portrayed holding up the severed head of Medusa. In the night sky, one eye in Medusa's head opens and closes and opens again. Arabic astronomers named the star Algol, the ghoul. Algol is an eclipsing double star. One star is bright, the other one, not that much. As the dimmer star orbits the bright star, it passes in front of the bright star, eclipsing it, and the eye closes. Since the dim star takes 2 days, 20 hours, and 49 minutes to orbit the bright star, the eye in Medusa's head opens every day and a half or so. The constellation of Perseus is immediately below Cassiopeia, and sky watchers quickly look to see if Algol is eclipsed, if Medusa's eye is open or closed. Perseus flew back from the Hebrides, accompanied by Pegasus, the winged horse. The central part of Pegasus is the Great Square, made up of 4 stars. As Earth goes around the Sun, the Great Square is right in the center of the night sky in autumn. In the summer triangle of Vega, Deneb, and Altair are in the middle of the night sky. In spring, it's Leo the lion, and in winter, it's Orion the hunter. These are the walls of the castle in the sky, and all have marvelous tapestries adorning them. The constellation of Andromeda shares a star named Alpheratz with Pegasus. It's one of the corners of the Great Square, so it appears Andromeda may be riding on Pegasus. Her crown, remember she is a princess, is floating nearby. M31, the Andromeda Galaxy. To see M31, cross the corners of the Great Square from the lowest star to the uppermost star, and then go a little further to see the Andromeda Galaxy. Be sure to peek at it from the corner of your eyes. It's called averted vision. The corners of your eyes are more sensitive to light, so you'll be able to see the huge spiral galaxy 2.5 million light-years away as a smudge of light 1.5 times wider than the full moon. Now, Perseus doesn't go in for human sacrifice, so he stops it and saves Andromeda by exposing Cetus to Medusa's gaze. And here we encounter the second eclipsing variable in our sky tapestry, Mira, the heart star of Cetus, the sea monster. Mira, from which we get the English word mirror, so fitting in a story about vain beauty, is an eclipsing double star. The dim star orbiting the bright star is a white dwarf, not bright enough to see with the unaided eye. The effect is that Cetus's heart shuts off. Mira is eclipsed and disappears. This cycle repeats itself every 332 days. Our fabulous star tapestry has the only 2 eclipsing binary stars visible to unaided eyes, the nearest spiral galaxy, and a hero that doesn't like human sacrifice and uses the scientific principle of reflection to thwart mythological monsters. Wow, I would hang that in my castle too. Just saying. Now tell me, what's the scariest thing in the universe? What, besides Darth Vader and a lightsaber? Well, actually, I was asking about black holes, swallowing anything that comes too close without doubts or regrets. Blinding supernovae, mysterious hypothetical wormholes. Yeah, probably not. Because the most terrifying things in the universe are likely to be rogue planets. Ooh. Nomads, orphans, sunless, unbound. That is what these creepy worlds are called. They have no sun. Unwanted in their star systems, they were once ejected into the soulless emptiness of space. And some of them didn't even have their own star systems. They were born lonely. Rogue planets don't have sunlight. The never-ending night reigns on their surfaces. No light means no warmth, and almost no chance of any kind of life to be able to survive in these frozen worlds. How lonely! Kinda makes you tear up a little. Okay, I'm done. But how do rogue planets get born? When planetary systems, including our solar system, form, it can get messy. Most planets appear from the cosmic dust that is floating in space around a newborn star. And when these planets form, they push one another. This gravitational game of tag often shoves some planets toward the edges of the newly formed star system. And sometimes, 1 or 2 of them get ejected from their home altogether. There are also nearby stars that can play with planets too. Stars aren't often born on their own. Clusters of dozens to thousands of stars can appear in space. And in such a crowded environment, it's not a rare occurrence when a star with its own planets steals away a planet or 2 from another star. After getting a new planet, it can keep it for itself or throw it away into the dark, deep cosmos. Some free-floating planets pop up in a different way, with no parent star to help them. Like stars, they form from collapsed clouds of gas and dust, but since they are too weak, They can't put on enough weight and can't start nuclear reactions that make stars emit light. Such planet-like objects are known as failed stars. Or planets can go rogue after their parent stars disappear. Yes, sometimes stars go out, destroying some of their planets in the process. At the same time, the most distant ones, located in a safer zone, are left more or less intact. But the enormous force of a supernova ejects these planets away from the former star at a tremendous velocity. In any case, astronomers think there may be more rogue planets in our home Milky Way galaxy than anyone ever suspected. A recent simulation has shown there might be billions of them. But the problem is rogue planets are very hard to detect. You know, it's a tricky feat to find any exoplanet, even when it belongs to a planetary system. After all, planets don't give off their own light like stars. That's why when astronomers want to locate an exoplanet, they look for something blocking the light of its parent star, and it's usually the very planet passing between the star and the observer. But researchers can't use the same technique with free-floating planets because there's no parent star and thus there's no light to get dimmer. Another method of detecting exoplanets is the radial velocity method. It detects the planet's gravitational effect on its parent star. But, as you may guess, it doesn't work with rogue planets either. Luckily, there are still some ways we can detect these space wanderers. Imagine a line of sight between a telescope on Earth and a distant star. When an object crosses that line, its presence is likely to bend and magnify the light of the star. This makes it appear brighter than usual. The trickiest part is to figure out whether this object is a rogue planet. It's true that the stars whose light such celestial bodies bend can't be their parent stars. They're too far away. But there might still be a small parent star invisible because of the glare of the main star. And astronomers have to wait for a long time, sometimes up to a decade, for the main star to move a bit. Then they can finally check if there's also a parent star out there. If there's no parent star in sight, then it's proven the planet is traveling solo. Not apparently. So far, astronomers have identified at least 70 rogue planets or candidate rogue planets. At the same time, we know about more than 5,000 exoplanets in planetary systems. That's a huge gap that proves that detecting rogue planets is a tricky business. Interestingly, free-floating planets might not be as lonesome as we think. They can potentially have moons of their own. They might even take them along when they get pushed out of their cosmic homes. But could a free-roaming world, and possibly its moons, find a new home near a different star? Some experts think it's unlikely. The universe is a very spacious place, and even a large star with an incredible gravitational pull is hardly able to catch a fast-moving planet. For example, in 2017, an interstellar guest, an asteroid the size of a skyscraper, appeared in our solar system. It barreled through the solar system and just kept going without stopping or even slowing down. Now let's have a look at a rogue planet we have managed to spot. Just 20 light-years away from the Sun, a bizarre rogue planet is roaming the Milky Way galaxy. And even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field, 4 million times stronger than that of our Earth. The exoplanet, with this crazy long name, also produces amazing auroras. When it was discovered a few years ago, astronomers were almost sure they had detected a brown dwarf. This is an object too large to be a planet and too small to be a star. But later, scientists got some evidence that the space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet of the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptionally strong magnetic field helps the planet produce such auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create these light shows. To find more amazing rogue planets, NASA's Nancy Grace Roman Space Telescope is going to conduct a survey using the powerful techniques of a wide-field telescope. The stars in our Milky Way galaxy move all the time, and chance adjustments of the telescope can help researchers spot rogue planets. But there's one drawback. We won't know the distance to such a planet even if we find one. There's one more mission concept called Cleopatra, the clever NASA acronym for the Contemporaneous Lensing Parallax and Autonomous Transient Assay. See, I told you it was clever. It might be able to exploit parallax effects to calculate the distances to rogue planets. Parallax is a shift in the position of a foreground object when seen by observers in slightly different locations. Could Earth one day turn into a frozen sphere aimlessly floating through space? Unlikely. Since our sun isn't going to blow up one day, our world isn't likely to be pushed out of the solar system by our star going supernova. But a rogue planet could cause life on Earth to end. Oh boy. One day, such a space intruder might push Earth out of the habitable zone near the sun and take its place. And our planet would have to retreat to an extreme orbit farther from the sun. The climate all over the planet would start getting colder and colder, turning first half of the planet, then our entire world into an icy desert. There would be a lack of food and other resources. It'd be getting darker and darker. There wouldn't be enough light for planets to get energy. They would wither, and animals that used to feed on them wouldn't be able to find food. Most species would go extinct. The farther our planet would be from the sun, the weaker the star's gravitational pull on our planet would be. In the end, our beautiful Earth would get too far away from its main source of light and heat. It would turn into a lifeless piece of rock covered with a thick layer of ice. Wow, bummer. But hey, don't worry, I guarantee that will never happen. At least not on my watch. A 40-year-long study has led astronomers to conclude that there's something seriously weird about Jupiter. The largest planet in the solar system doesn't seem to have seasons. The measurements have been taken both by spacecraft and ground-based telescopes. They showed bizarre weather patterns on the gas giant. For example, cold and hot periods throughout the year, which equal 12 Earth years. And at the same time, Jupiter doesn't go through seasonal changes like our planet. On Earth, weather changes between winter, spring, summer, and fall because of the tilt of our planet's axis toward the plane in which it orbits the Sun. This tilt, which is 23 degrees, allows different parts of the globe to receive different amounts of sunlight throughout the year. But Jupiter's axis is tilted toward its orbital plane by a mere 3 degrees. It means that the amount of sunlight that reaches different parts of the planet's surface throughout its long year hardly changes. But the new study has found that there are still certain temperature swings that take place all over the gas giant's cloud-covered globe. Astronomers claim they've solved one part of this puzzle. They've found some hints that such unseasonal seasons might have something to do with teleconnection. This phenomenon describes periodic atmospheric changes in seemingly unconnected parts of the globe, which can lie thousands of miles apart. Scientists have observed teleconnection in the atmosphere of our planet too. One of the most famous examples is known as the Southern Oscillation. That's when changes in the trade winds of the western Pacific Ocean correspond with changes in rainfall across large territories of North America. As for Jupiter, when temperatures rise in specific regions of the planet's northern hemisphere, the same latitudes in the southern hemisphere cool off. Further research also revealed that when temperatures rise in the upper layer of Jupiter's atmosphere, called the stratosphere, it gets colder in the troposphere. This is the lowest atmospheric layer where weather events, such as Jupiter's powerful storms, occur. Researchers hope that by measuring all these temperature changes, they will eventually be able to make a more or less precise weather forecast for Jupiter. Maybe in the future, they will even be able to extend this to other gas giants to see if they have similar patterns. But this isn't the only mystery the gas giant can boast. Let's have a look at some other, no less intriguing puzzles. For example, a 2018 study that found that Jupiter had a delayed growth spurt. You might have heard that the most popular theory about the beginning of the solar system says that, at first, the Sun was orbited by a dust-filled gas cloud. Some time passed, and tiny pieces gathered together into lumps, which later formed planets. But Jupiter was the odd kid. It started off well, The gas giant was gathering around small clumps of matter for 1 million years or so. But once it grew to be as massive as 20 Earths, its development suddenly stopped. It could have happened after bizarre zones appeared in space. They emitted so much heat and energy that gas molecules struggled to merge with young Jupiter. This period continued for 2 million years. During this time, Jupiter only grew to 50 times the mass of Earth. But once this stage finished, the planet continued to gobble down gas like before, and soon it swelled to its current mass, about 300 Earths. Jupiter's most famous feature is the Great Red Spot, a giant storm raging in the atmosphere of the planet and capable of engulfing 2 Earths. But few people know about the Great Cold Spot. It was spotted only recently when astronomers were checking data received by an observatory in Chile. It's believed that Jupiter's auroras spawn this unusual patch, which is around 400 degrees Fahrenheit colder than the surrounding areas. These auroras are ancient. It makes the spot thousands of years old. And unlike the Great Red Spot, it's not stable. It keeps shape-shifting, and sometimes it almost disappears. But it always returns to the upper atmosphere. Usually it happens after a powerful auroral display. Now, storms are no stranger to Jupiter's atmosphere. But where there are storms, there is lightning, right? Yeah, but the bolts of lightning on Jupiter turned out to be very strange. They release radio waves, which is not strange, but for decades, every spacecraft visiting the gas giant managed to record something bizarre. You see, Jupiter's lightning only signaled in the low-frequency range, and no theory could explain why, since lightning on Earth emits radio waves from low to very high frequencies. Finally, in 2018, the Juno space probe solved this mystery. Apparently, the problem was not with the gas giant, but with our technologies. Unlike previous spaceships, Juno had extremely sensitive equipment, and it came very close to Jupiter, so it did record both megahertz and even gigahertz strikes. But even Juno confirmed that lightning on Jupiter was totally different from lightning on Earth. On our planet, lightning avoids the poles. It prefers to zap the equator. Meanwhile, the gas giant's equatorial zone sees no lightning. It lights up the planet's poles, and its peak frequency is 4 bolts per second. In 2017, when astronomers were searching for the theoretical Planet X, they noticed that some object outside the solar system was tugging at objects within. Thinking it could be what they had been looking for, they turned a powerful telescope in that direction. Coincidentally, that patch of sky contained Jupiter. And even though the researchers didn't find Planet X, they noticed 10 previously unknown moons orbiting the gas giant. This brought the number of the planet's satellite to a total of 79. But the coolest thing was that one of the newly discovered moons was very unusual. The thing is, Jupiter's moons move in packs, so 2 of the new satellites were spinning with a group that rotated in the same direction as the gas giant, and the rest was in a cluster spinning against the planet's rotation. As for our weird guy, it was inside the second group but spinning with Jupiter. Unfortunately, it means that the moon will most likely have a short lifespan. An anti-retrograde moon within a retrograde cluster won't be able to avoid a collision. Look at Jupiter's beautiful patterns. Look at these swirls and stripes. For a long time, no one knew the depths of these bands. But in 2018, scientists used a novel way to crack this riddle. This method involved the space probe Juno, which orbited the gas giant every 53 days. Each time it passed by, it measured how strong the pull of the planet's gravity was. It helped astronomers create a 3D image of the stripes. It goes like this. The greater the pull, the greater the mass of the region below. And after examining the gravitational map, researchers concluded that the stripes ran shockingly deep. Most of them plunged to a depth of 1,800 miles. But Jupiter is a gas world, and the winds raging in its atmosphere shift all that mass around, making calculations very difficult. Jupiter has the strongest magnetic field of all the planets in the solar system. It's 20,000 times more powerful than that of Earth. But the gas giant's magnetosphere is a bit wacky. It's unique and doesn't resemble the field of any other planet we know about. Before, experts thought that Jupiter's magnetic field was similar to Earth's, two poles connected with magnetic lines near the geographical north and south. But Juno showed that things on Jupiter are a bit messed up. The magnetic South Pole is pretty well behaved, but the North Pole is a different story. Intensely magnetic ribbons and chaotic pieces of field, some of them without even positive or negative counterparts. Plus, there seems to be another South Pole. It might be that Jupiter's hydrogen ocean generates the magnetic field of the planet. And if scientists manage to solve the mystery of Jupiter's magnetosphere, they might also find out what's happening inside the gas giant. But first, they need to understand the bizarre behavior of the planet's poles.
Hey space buffs, just how well do you know our solar system? Guess the planet. It's more than twice as massive as all the other planets combined. It's covered with striking swirls and stripes, which are actually windy clouds of cold ammonia and water, floating in an atmosphere of hydrogen and helium. Still no clue? Then look at this. It's the infamous Great Red Spot, a giant storm larger than our home planet that has been raging for hundreds of years. Right you are. This cloudy world is Jupiter, and the main question is this planet our enemy or friend? NASA's Juno orbiter is exploring this gas giant at the moment, sending us tons of useful data. Jupiter is so big that 11 Earths could fit across its equator. If our planet was the size of a grape, Jupiter would be a basketball. The gas giant is the fifth planet from the Sun, orbiting around 484 million miles away. And even though for us Earthlings, our blue-green world seems to be the most important among all the other planets, we live in Jupiter's solar system. After all, it accounts for 75% of the mass of all the planets in our star system. And it's also 318 times more massive than Earth. And whatever Jupiter wants, Jupiter gets. Jupiter wants to throw stuff across the solar system? No problem. After all, this gas giant doesn't have its immense gravity for nothing. It yanks material from the asteroid belt, stopping poor space rocks from forming anything larger than Ceres, the only dwarf planet located in the inner solar system. Jupiter is hungry, it gobbles up comets, asteroids, and whatnot. Jupiter's bored. It hurdles everything it manages to capture on wayward trajectories. This gas giant must have caused a lot of destruction over the course of its life, which is around 4.5 billion years. But here's the thing. Some scientists think that we might owe our very existence and the existence of our planet to Jupiter's protective gravity. It may sound confusing, but by greedily swallowing up dangerous space objects, this planet vacuums the solar system. Other astronomers don't agree with this theory. They claim Jupiter is a hooligan, bothering peaceful and safe comets and sending them to unexpected places. You see, some of the most dangerous objects in our solar system are long-period comets. Those are huge chunks of ice and rock coming from the depths of the Oort cloud, which lies far beyond Pluto. Some of them get pushed into the inner solar system, where they dash past the Sun. There's a chance that the most devastating extinction on Earth was caused by a long-period comet. As such comets make their way through the solar system, they likely interact with Jupiter's gravity. The gas giant pushes them this way and that, consuming some of them like delicious ice rock burgers. But does Jupiter push such comets out of their dangerous orbit so that they don't smash into Earth? Or does this gas giant actually divert the trajectories of the comets that would otherwise miss Earth? No one knows. Astronomers sometimes call Jupiter a failed star. The gas giant indeed contains a lot of helium and hydrogen, the material stars are mostly made of. But the planet's mass isn't enough to start a fusion reaction in its core, and that's exactly how stars produce energy. They fuse the atoms of hydrogen together under extreme pressure and heat and create helium. In the process, they also release light and heat. Jupiter could start a nuclear reaction and become a star only if it was 75 times its current mass. Paradoxically, if Jupiter even got more massive, it would also get smaller. This additional mass would make the planet denser, and it would cause the gas giant to start pulling it in on itself. Astronomers are almost sure that even if Jupiter was 4 times its current mass, it would still remain the same size. Jupiter has between 80 and 95 moons, but one of the most popular ones these days is Europa. Imagine a still, frozen world. It's ancient, about 4.5 billion years old. It's barely heated by the rays of the sun and covered with a thick layer of ice. This world is smaller than our moon, but a bit larger than Pluto. That's what Europa, the 6th satellite of Jupiter and one of the biggest moons in the solar system, looks like. And the coolest thing about this faraway place, it might host life. Astronomers consider Europa to be one of the most promising places in the solar system to search for new forms of life. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it's still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. For a long time, scientists have been wondering about Jupiter's X-ray auroras. What causes them? It seems like the 40-year-old mystery has been solved. Jupiter's breathtaking X-ray auroral emissions are triggered by electrically charged particles called ions. They crash into the gas giant's atmosphere, and here's the result. But astronomers couldn't understand how those ions got to the atmosphere in the first place. But recently, they've seen the ions surfing Jupiter's magnetic field all the way down to the planet's atmosphere. Astronomers have received this data thanks to NASA's Juno spacecraft and ESA's XMM Newton telescope, situated in Earth's orbit. Now, on our home planet, auroras are only visible in a belt surrounding the magnetic poles, between 65 and 80 degrees latitude. Anything beyond 80 degrees and auroras disappear. But Jupiter's X-ray auroras are much more inconsistent. They pulsate regularly poleward of the main belt, and sometimes they're different at the north and south poles. Scientists have figured out that this pulsation is caused by the fluctuations in Jupiter's magnetic field. You see, when the planet rotates, it drags behind its magnetic field. Struck by the particles of the solar wind, it gets compressed. This heats the particles trapped in Jupiter's magnetic field, and they start moving along the magnetic field lines, producing magnificent auroras. Another feature Jupiter is famous for is its Great Red Spot, an enormous storm raging in the southern hemisphere of the gas giant. Its top parts tower more than 5 miles above the surrounding cloud tops. The storm is more than twice as wide as our planet. At the edges of the storm, the wind speeds reach 270 to 420 miles per hour. That's faster than Earth's tornadoes. The hot gases in the planet's atmosphere are always moving, rising, falling, and swirling. Just like on our planet, when cooler and hotter gases mix and merge into one another, they form giant circling storms. Astronomers think that once several enormous storms could have come together, creating the Great Red Spot. And now it keeps raging by constantly drawing cool gases from below and hot gases from above. Plus, this monster of a storm absorbs other, smaller vortices. They make the spot even more powerful. Several theories try to explain why the storm has its trademark color. It varies from whitish and pale salmon to orange and brick red. Some scientists believe the answer lies below the Great Red Spot, closer to the planet's surface. A colorless layer of ammonium hydrosulfide might be reacting with the cosmic rays or the UV radiation coming from the sun. This somehow gives the spot its pretty red color, but so far, it's just a theory. Astronomers have been observing the Great Red Spot since the 1830s. And for the first time, the storm was spotted in 1665 and described as the permanent spot. In other words, the storm is almost 400 years old. Strangely, it's been shrinking in size since the beginning of the 21st century. In 2019, it began flaking at the edges, with small pieces breaking off and vanishing. If this process continues, by 2040, the Great Red Spot might become circular, or it may simply disappear.
Picture a tiger. Tigers are known for their beautiful stripes, which they always keep the same. However, imagine if the tiger's stripes could change their size, position, and colors from time to time. Magical, right? But that's exactly what happens with one titan of our solar system, Jupiter. Why and how? Well, astronomers might just have the answer, so let's see. Jupiter is a huge and fascinating planet. When you're looking at its picture from far away, it's like seeing a beautiful sunrise. Here we have an entire palette, from creamy pale yellows to caramel browns, with even some blue shades. Jupiter is a fascinating place made mostly of hydrogen and helium, just like our Sun. However, it didn't gather enough stuff during its formation to become a star. Instead, it became a colossal ball of gas that could fit more than 1,300 Earths inside. Jupiter has these interesting patterns of dark and light clouds that go around the planet in alternating bands like giant stripes. These dark stripes are called belts, and lighter ones are called zones. Actually, it's not unique in this. Earth and Jupiter both have these cool patterns in their atmospheres. It's just that Earth has a few of them, but Jupiter has a lot more. Why are these belts brown and beige? Those can be explained by the combination of hydrogen, helium, and other trace elements in the planet's atmosphere. It's like mixing different colors of paint to create new shades. These belts create beautiful patterns across the planet's surface. Now, because Jupiter has such a massive atmosphere and a weather system similar to Earth's, it experiences some extraordinary storms. So even though these stripes may look calm and peaceful, they're actually part of a wild weather system. It's like a never-ending storm party happening there. These belts and zones move in opposite directions around the planet. The belts go against Jupiter's rotation, like going against the flow, while the zones go with it, joining the dance. And not only do they move in different directions, but they also exist at different heights in the planet's atmosphere. The belts are like regions where things are rising up, like bubbles in a fizzy drink. So the cloud tops in the belts are higher up in the sky compared to the cloud tops in the zones, which are more like sinking areas. So, even though Earth and Jupiter have this similarity, their weather is completely different. It's like comparing apples and oranges. One of the most famous storms on Jupiter is the Great Red Spot. But why is it red? Well, that's a bit of a mystery. Scientists think that the storm sits at a higher altitude than the rest of the atmosphere. This means it gets a stronger dose of sunlight. Imagine standing on a hilltop where the sun shines brighter on you compared to the surroundings. In a similar way, the Great Red Spot gets more radiation from the sun. The storm also contains some special chemicals in its clouds, like ammonia and acetylene. When these chemicals receive that extra radiation, they react in a unique way, giving the storm its distinct red color. It's like a special effect in a cosmic theater. Anyway, the stripes look pretty cool and all. But what's the big mystery around them? Well, you see, one day scientists decided to look at data from deep inside Jupiter, about 30 miles below the surface. And after peeking in Jupiter's secrets, they noticed something strange. When they looked at Jupiter using a special type of light called infrared, the colors of its stripes actually switched around. The light bands that were pale and creamy in normal pictures become dark in the infrared view. The dark bands that were belts before now shined brightly in the infrared. This suggests something interesting. The belts on Jupiter have thinner cloud coverings compared to the zones. It's like the belts are wearing sheer, see-through outfits, while the zones have thicker clouds, like fluffy jackets. So, what we see as dark bands in normal pictures turn out to be bright in the infrared, hinting that these belts have less cloud stuff blocking the light. But here's the most strange part. Every few years, something changes. It's like the weather on Jupiter goes through a wild roller coaster ride. The colors of the belts can change, and sometimes the whole weather pattern becomes a bit crazy for a while. Scientists have been scratching their heads, trying to figure out why this happens. So they've decided to use a special spacecraft called Juno to investigate this. Since 2016, Juno has been gathering a lot of information about Jupiter, like a spy collecting clues. One of the things Juno has been looking at is Jupiter's magnetic field. Just like Earth, Jupiter has a magnetic field. It's like an invisible bubble that surrounds the planet, extending to space. This magnetic field is really important because it protects the planet and everything on it. It acts like a shield against harmful particles from space, like those coming from the sun. But Jupiter's way bigger than us, so his protective shield is much stronger. Magnetic fields are generated by something called a dynamo, which is like a big swirling conducting fluid inside the planet. This fluid moves around and rotates, kind of like a dance party happening deep within the planet. So, scientists have been looking at the data collected by Juno over the years and noticed something interesting. Jupiter's magnetic field has its own little motions, kind of like when you see waves in the ocean. Scientists call these motions torsional oscillations, which is just a fancy way of saying wave-like movements. It's like Jupiter is doing its own magnetic dance. Now let's imagine that Jupiter's insides are like a giant pot of boiling soup. Deep within Jupiter, there are slow currents that carry heat upwards, just like a conveyor belt. This heat eventually reaches the upper part where we see the clouds. But here's where things get interesting. Imagine someone starts stirring the soup really fast with a spoon. Those wavy magnetic movements, the torsional oscillations, act just like that spoon. They create a disturbance that messes up the slow currents. Now this disruption has a big impact on Jupiter's weather. It's like turning up the heat in the kitchen and changing the way the soup cooks. The patterns of rising and sinking in the clouds, which we call upwelling and downwelling, get all mixed up. A whirlwind in the soup. Our clever scientists also noticed something special near Jupiter's equator. They discovered a concentrated spot of magnetism called the Great Blue Spot. And guess what? This spot is slowing down, like it's taking a break from its usual fast movement. This suggests that a new type of wavy motion, a new dance, is about to begin. So, to sum it all up, the scientists have come up with a cool idea. These wavy magnetic movements, the torsional oscillations, disrupt the slow currents inside Jupiter, messing up the cloud patterns and causing wild weather. And when the scientists calculated the time it takes for these wave-like motions to happen, they discovered that they match the same time periods when the stripes on Jupiter change. So, in simple terms, the scientists think that these wave-like movements in Jupiter's magnetic field are causing the changes in the stripes on the planet. Pieces of a puzzle are coming together. Scientists are still trying to fully understand why this happens, but it's an exciting step forward in unraveling the mysteries of our vast universe. But there are still some mysteries left to solve. To find more answers, scientists need to keep watching Jupiter closely in the future. By observing how the clouds change, they can check if their theory is correct or if it needs some adjustments. From its massive storms to its colorful belts, Jupiter never fails to amaze us with its cosmic wonders. It may not have ignited as a star, but it shines brightly as a gas giant, captivating us with its size and beauty. So keep your curiosity alive and always reach for the stars.
As scientists continue to explore the vast expanse of the universe, they've made some incredible discoveries that have left them with more questions than answers. From a scorching super-Earth to a football-shaped world, the exoplanet discoveries of 2022 are truly out of this world. So, hold on tight, the future of exoplanet discoveries is looking brighter than ever. Number 1. new type of exoplanets. Red dwarfs make up over 70% of all stars in space. So, in September of 2022, scientists decided to take a closer look at the small worlds orbiting them. What they found was amazing. New type of exoplanets that were made of half rock and half water, either in liquid or ice form. The researchers suggested that these planets likely arose from icy material and were born far away from their stars, past the ice line, where surface temperatures are freezing. But they later migrated closer in, to where the astronomers detected them. This discovery could have huge implications in the search for life in the cosmos. Though these planets are loaded with water, they might not be covered in oceans. Who knows? Maybe one of them will be the next Earth 2.0. Number 2. Jupiter-sized world. Imagine a planet so massive and mysterious, it's like a hidden Jupiter in our galaxy. Well, we just discovered one of those orbiting a star just 379 light-years away. Just. We've named it the TOI 2180b, and it's got everyone talking. Why? Well, for starters, this planet takes a whopping 261 days to orbit its star, which is much longer than most distant gas giants we've come across so far. But that's not all. The temperature on this world is surprisingly mild, averaging at a balmy 170 degrees Fahrenheit. For comparison, the temperature on Jupiter and Saturn is around minus 280 degrees. It's like a bridge between the giant exoplanets we've found and our Jupiter. But the question remains, how did this planet get to be so different? Scientists are still trying to figure that out. Let's hope that we get some answers soon. Number 3. The Hulk planet. This world is a place where the surface is covered in molten magma, and the year lasts just half a day. Welcome to TOI 1075b, an exoplanet that's been dubbed the planet Hulk by scientists. Located 200 light-years away, this super-Earth is one of the most massive ever discovered. Its proximity to its parent star causes its surface to reach scorching temperatures of 1922 degrees. It's so hot that any form of water would evaporate instantly, and the air would be filled with vaporized rock. But it's not just the heat that's impressive, it's also its size. TOI 1075b is nearly 10 times the mass of Earth, making it one of the most massive super-Earths ever discovered. But the mystery doesn't stop there. The planet's orbit takes just 14.5 hours, making it one of the shortest orbital periods ever recorded for a planet of its size. What an exciting addition to our catalog! Number 4. 3 doomed planets. Astronomers made a shocking discovery of 3 planets that are circling in a dangerous dance next to the slowly fading stars. Just a decade ago, scientists never even imagined such planets could exist. These gas giant planets, similar in size to Jupiter, orbit way too close to their slowly fading stars. They're basically walking on the edge. Take one of them, for example, dubbed TOI 2337b. Its orbit will likely send it hurtling straight into the fiery arms of its host star in less than 1 million years. Well, I won't be around then. As these stars enter their final days, they're pulling in nearby planets like a black hole, altering their orbits and potentially causing catastrophic collisions. And as these planets get closer to their stars, their atmospheres heat up and swell, leading to some mind-boggling differences in density. But despite the doom and gloom, studying these worlds could give us valuable insights into the evolution of our own solar system. Number 5. Planet with a barium's atmosphere. These are 2 hot blazing planets, each with an atmosphere made of the heaviest element ever found in an exoplanet, barium. These planets, known as WASP-76b and WASP-121b, are ultra-hot gas giants called superjupiters that orbit incredibly close to their stars. These planets are basically like giant balls of fire, with one side facing the star, cooking at temperatures hot enough to vaporize iron and other metals. But as the hot iron vapor is blown into the planet's cooler night side, it turns into liquid and falls as iron rain. And these planets held a special surprise for us. Barium is a heavy metal, about 2.5 times as heavy as iron. And yet, scientists were able to detect it in the upper layers of these planets' atmospheres. This is truly a mystery and a puzzle we're still trying to solve. Imagine landing on a planet like this and looking at this rain of iron and the heavy barium in its skies. That would be awesomely horrifying. Number 6. The Football Planet. Get ready to have your mind blown, space enthusiasts, because we've just discovered the ultimate football-shaped planet, and it's unlike anything we've ever seen before. Meet WASP 103b, the ultra-hot exoplanet that's more than 1,000 light-years away from Earth. This gas giant is so close to its parent star that its shape is being stretched by the intense gravitational forces. But this isn't just a fun shapeshifter. It's also a valuable scientific discovery. By studying the planet's passes across its star, we were able to measure its deformation for the first time ever. It's like taking a snapshot of a planet in motion, and it's giving us insights into the extreme conditions that these planets can endure. This is truly a great discovery. Number 7. A zodiacal light. Are you ready for a cosmic ghost story? Scientists and high school students in China have uncovered a spooky phenomenon on 3 distant exoplanets. It's called zodiacal light, a glow that's similar to the one seen here on Earth during sunset. But this isn't just some eerie light show. It could hold clues about the makeup of these potentially habitable worlds. Imagine watching the sunset from a dark spot on Earth, and instead of darkness, a triangle of light appears. That's zodiacal light. It's caused by sunlight reflecting off dust particles that fill the solar system, the remains of asteroids and comets. A team of researchers analyzed 47 potential habitable exoplanets named Kepler 69c, Kepler 1229b, and Kepler 395c, all super-Earths, had signs of this light. This discovery is more than just a spooky phenomenon. It could reveal information about the presence of asteroids and comets in these exoplanet systems, which could be difficult to detect otherwise. So that's pretty neat. Number 8. A planet with silicate clouds. Introducing VHS 1259b, not a home video recording system, but a strange and exotic world shrouded in mystery and wonder. A place where the clouds are made of sand and the sky is forever red. This isn't the stuff of science fiction, but a real-life discovery made by the brilliant minds at NASA. This is a brown dwarf exoplanet that's making waves in the astronomical community. It's way too massive for a planet, nearly 20 times the size of Jupiter, but it's not quite a star. It's something in between, a cosmic enigma that defies definition. But what's really crazy about VHS 1256b is its atmosphere. Scientists have discovered that this strange world is cloaked in thick clouds of silicate grains, similar to sand. It's the first time this kind of cloud has ever been detected on an exoplanet, and it's a discovery that's sure to change the way we think about the universe and the possibilities of life beyond our world. And there you have it, folks. The year 2022 was filled with incredible discoveries and groundbreaking findings in the world of exoplanets. But this is just the beginning, as scientists and researchers continue to explore the vast expanse of space. We can only imagine what other wonders await us. So, let's keep looking. Who knows what secrets the stars hold for us next?
From planets with glass rain and oceans of lava, to worlds with 3 suns and giant diamonds, our universe is full of surprises. Sometimes we find celestial bodies that shouldn't even exist at all. But despite all logical reasoning, they live and thrive. In 2023, we discovered another impossible planet, TOI 5295b. Once again, our universe turns out to be much more complicated than we thought, and this isn't the only strange planet that we've discovered in recent years. So, let's take a look at a couple of these impossible planets. TOI 5205b is the first one on the list. This is an unusually large planet orbiting a small star. It's located about 280 light-years from Earth. It's quadrillions of miles, but on a cosmic scale, it's pretty close. This planet was discovered just recently, in 2023, So why is it so special? Because it doesn't follow the rules of planetary formation, like other planets in its neighborhood. TOI 5205b is a bit of a rebel because it orbits a tiny red dwarf star that's only 4 times larger than Jupiter. What's so weird about it, you ask? Well, you see, a red dwarf is basically like the runt of the litter in the world of stars. This type of star is rather cold, about 2 times colder than the Sun. They have a reddish tint, hence the name. And yep, stars work quite strangely. The closer they are to red, the colder they are, and the closer to blue, the hotter they are. Hey, I don't make the rules. Anyway, because of all this, they aren't very bright. So without a good telescope, you won't see them in the sky. But they aren't just some space losers. They're the most common stars in the universe. They also live much longer than our Sun, and thanks to this, they usually have a bunch of different planets orbiting them, including those similar to our Earth. So if one day we decide to find a new home, it may well be near some red dwarf. But here's the catch with TOI 5205b. It's a gas giant. Gas giants like, for example, Jupiter or Saturn, are the behemoths of the universe. These planets are mainly made up of gases like hydrogen and helium. They don't have a solid surface like Earth or Mars, so you can't exactly land on them without getting crushed by the immense pressure. And they're not called giants for nothing. They're absolutely massive. In fact, if you took all the other planets in our solar system and squished them together, they still wouldn't be as big as Jupiter. In other words, they're the gassy wrestlers of the planetary family. So, how is it possible that such a huge planet orbits such a small, weak star? Red dwarfs are usually considered too small to host gas giants. Moreover, it's physically impossible. Or at least, so we thought. But TOI 5205b had other plans and decided to form near a red dwarf anyway. It's like a small pea orbiting around a lemon, which doesn't sound that bad until you remember that Jupiter next to our Sun is like a pea next to a basketball. Only really big stars are able to keep such big planets nearby. This had astronomers scratching their heads as it went against everything they thought they knew about planet formation. And while we try to figure out how TOI 5205b managed to break the rules, the planet itself seems pretty content to blaze its path through the cosmos. And it isn't the only one. In recent years, scientists have discovered a bunch of such forbidden planets. So let's check out the other ones. For example, TOI 3757b, a giant planet with the density of a marshmallow. Imagine a giant planet that's so soft and fluffy it's like a marshmallow floating in space. That's right, TOI 3757b is a gas giant that's been dubbed the Marshmallow Planet because of its incredibly low density. Of course, it's not edible and cute like real marshmallows, but it would still be fun to touch it. This planet was discovered in 2022. It's located in the constellation of Auriga the Charioteer, 591 light-years from us. Just like the previous one, it's also orbiting around a red dwarf star. And get this, TOI 3757b only takes around 3 days to complete one orbit. Imagine having a birthday every 3 days. It's also incredibly close to its star, just some 3.5 million miles away. For comparison, the distance between the Sun and the planet closest to it, Mercury, is about 36 million miles. So TOI 3757b is like right on top of its star. Let's hope this marshmallow planet doesn't get too toasted. Now let's talk about how this planet was discovered. It was spotted by the Transiting Exoplanet Survey Satellite, or TESS, a space detective on the hunt for new planets. The transit detection method is when scientists use the star's light to find their planets. When the planet passes through the star, it blocks a tiny portion of the star's light, making it look a little dimmer for a while. Scientists can detect this dip in brightness using special instruments, If the dip happens regularly, they can tell that there's a planet orbiting the star. The size of the dip in brightness tells scientists how big the planet is and how close it is to the star. If the dip is really small, that means the planet is probably pretty small too. And if the dip happens more frequently, that means the planet is probably closer to the star. And this is how we discovered our marshmallow planet and many other ones. Overall, TOI 3757b is a fascinating planet that's captured our imaginations with its unique properties. Now, let's move on to the next mysterious celestial body. TYC 8998-760-1b on the border of a planet and a star. Whew, that was a mouthful. Let me introduce you to a planet whose name I won't repeat. Well, this baby is also a gas giant. But not just any gas giant. In fact, it's so big, it could make Jupiter feel like a tiny pebble in comparison. I mean, it's 14 times the mass of Jupiter and 3 times as big around. Isn't that impressive? It orbits a very young, sun-like star 300 light-years away. This star is only 17 million years old, and yes, it's considered a baby among the stars. For comparison, our own Sun is about 4.5 billion years old. But the star itself isn't that interesting. The planet, on the other hand, is a bit of a weirdo. You see, planets just can't be that big. With its enormous mass, it should be a star. It's kind of like the Caspian Sea, which is considered the largest lake in the world. Just as the Caspian Sea isn't really a sea or a lake, this planet is the middle child of the universe. Not quite a star, but not exactly a planet either. Some scientists think that it might be a failed star, which is like saying a cake that didn't rise properly. And let's talk about its temperature. You know how you feel like a baked potato when it's 90 degrees Fahrenheit outside? Well, this planet laughs at us. Its estimated surface temperature is a whopping 2,600 degrees Fahrenheit. That's hotter than a jalapeno popper straight out of the fryer. This time, the planet was discovered by the imaging detection method. You see, capturing pictures of exoplanets is no easy feat. The star is always way brighter and ruins the pic. It's like trying to take a selfie with your crush while your annoying little sibling is jumping up and down in front of you. But scientists have a solution. They use some specialized optics and clever observation methods, like coronography. They basically block out the light of a star so that we can see the planet more clearly. Magic, right? And that's how they discovered this not-a-star planet too. And now it's giving scientists a lot to think about. It makes us question what we know about the formation of planets. Let's hope we'll find out more about it in the future. It's amazing to think about the weird and wacky things that exist in our universe, and these planets definitely fit the bill. Who knows what else is out there waiting to be discovered? Maybe someday we'll find a planet that's even more impossible than the ones we just discussed. Until then, keep your eyes on the skies and your mind open to the infinite possibilities of our universe.
So, planets with 2 suns, like Tatooine from Star Wars, used to sound like pure fantasy. For decades, scientists believed these systems were too unstable to exist. 2 stars tugging at a planet should fling it into space or drop it into one of the suns. Except, it turns out that nature didn't get the memo. Astronomers have found a planet calmly orbiting 2 stars like it's no big deal. This planet lives closer to its 2 parent stars than any other directly imaged planet in a binary star system astronomers have ever seen. Now, direct imaging means they saw the planet's light, not just its shadow. The whole system sits about 446 light-years away, so the light we see from it today left before humans ever built modern cities. This space monster is roughly 6 times the mass of Jupiter. And even more surprising, the planet is only about 13 million years old. That sounds ancient until you zoom out a little. Earth is about 4.6 billion years old, which makes this planet basically a newborn in cosmic terms. The 2 suns of this monster orbit each other incredibly fast and complete a full loop in just 18 Earth days. That means their gravity constantly shifts, yanking space around them like a cosmic washing machine. Even so, the planet stays locked in its path, so it takes it 300 Earth years to finish a single orbit. So nobody fully understands how this planet formed in the first place. When two stars orbit each other this closely, their gravity usually tears apart planet-forming material before anything big can take shape. Scientists have only found a few dozen planets like this so far, and that's nowhere near enough to piece together the full story. To solve the mystery, they need more data. Now, another cool find that still needs more research is a planet so stretched by gravity that it looks like a lemon, not a sphere. This planet is nothing like the calm blue and green worlds we see in space movies. It orbits a pulsar, which is basically a star's corpse. When a massive star expires, it collapses into an ultra-dense object that spins insanely fast and blasts radiation like a cosmic lighthouse. Being near one of those means game over for anything solid. And yet, this planet hangs on, barely. The gravity stretches it, pulling harder on the side facing the pulsar than the far side, like cosmic taffy. And here's where it gets extra unsettling. When scientists analyzed this planet's atmosphere, they didn't find water or oxygen. They found helium and pure carbon. No clouds, no oceans, no chance of life. According to everything we know about planet formation, this world shouldn't exist at all. So it might not be a planet in the normal sense. It could be the exposed core of a star that got shredded, leaving behind something stuck between planet and stellar corpse. That's a pretty scary trend. The line between planets and stars keeps getting blurry. And speaking of scary, meet this guy. This system lives around two red dwarf stars. These two stars orbit each other at a distance similar to how far Jupiter sits from the Sun. Scientists found two Earth-sized planets and a third possible one squeezed right up next to the stars. One planet completes a full year in just over 2 days. Another takes about 3.5 days. The candidate planet orbits even faster. To put that in perspective, these planets sit less than 2 million miles from their star. The Moon sits about 250,000 miles from Earth. So yeah, these worlds are close. When they combined data from space and ground-based telescopes, astronomers realized they were staring at something totally new: planets that transit or pass in front of both stars. Most planets in double-star systems orbit only one star, and this setup shouldn't last long according to the rules of physics. But these planets exist anyway, calmly breaking the rules. So this guy proves that planet formation works in ways we still don't fully understand, and space clearly enjoys messing with our expectations. Now, let's crank up the horror a notch. Astronomers made the first ever 3D map of a planet outside our solar system. And not just any planet. This one is so hot, it literally tears water molecules apart. As the planet moved behind its star, the James Webb watched tiny changes in the star's light at different colors or wavelengths. Some colors get absorbed by water vapor, others don't. By stacking all that info together, scientists figured out temperatures at different heights and locations in the planet's atmosphere. And that's how they learned that parts of its atmosphere heat up to nearly 5,000 degrees Fahrenheit, hotter than molten lava. This superhot planet sits about 400 light-years away and weighs around 10 times as much as Jupiter. It races around its star in just 23 hours. 1 year there is basically a day. And because it's so close, the temperatures get so high. Winds try to move heat around, but they totally fail. WASP-18b's atmosphere barely has any water and instead overflows with carbon monoxide. Astronomers once believed water should be common in giant planet atmospheres. This world proves water is optional, not guaranteed. Now, magma worlds are another perfect proof of that. There's a huge group of planets called sub-Neptunes, planets bigger than Earth but smaller than Neptune. For a while, some scientists hoped these worlds were Haitian planets, covered in deep oceans of water or ice, wrapped in thick atmospheres. One famous example was K2-18. Its atmosphere showed methane and carbon dioxide, but almost no ammonia. But as it turned out, lava dissolves ammonia too, so the missing ammonia doesn't prove water at all. It could just mean the planet has a global ocean of magma instead. The researchers model how these planets heat up, cool down, and evolve over time. They asked a simple question: do these planets ever cool enough to stop being lava worlds? And the answer was almost never. When they tested thousands of known sub-Neptunes, they say almost all of them are likely lava worlds, not water worlds. In simple terms, these planets don't breathe water vapor, they breathe rock vapor. Their atmospheres come from magma boiling, not oceans evaporating. And that changes everything. Many worlds we once labeled maybe habitable turn into hellscapes the moment you run the numbers honestly. And that means space isn't hiding Earth clones, but mass-producing furnaces and other sorts of monsters. Take this bad boy, for instance. It sits only about 64 light-years away, which is uncomfortably close in cosmic terms, and it's the nearest hot Jupiter to Earth. From afar, it looks stunning, a smooth, deep blue marble floating peacefully in space. But that color hides something absolutely brutal. On this planet, it rains glass, sideways. Winds scream across the atmosphere at around 5,400 miles per hour, fast enough to shred anything instantly. The blue color comes from tiny particles of silicate, the stuff glass is made of, floating in the air. The planet's surface temperature hits about 2,400 degrees Fahrenheit, hot enough to melt rock. That heat turns those silicates into microscopic shards of glass that whip around the planet like a worldwide sandblaster. Standing there wouldn't hurt. You wouldn't exist long enough to ever feel it. And then there's the darkest planet ever found. It reflects less than 1% of the light that hits it. It's darker than coal, darker than black paint. Light just disappears into it. Not all planets even bother with stars at all. Astronomers have found rogue planets, worlds kicked out of their solar systems. These lonely planets drift through space in total darkness, frozen and untethered, with no sunrise ever again. Now, all of this shows us that our universe isn't designed for life. Life survives despite the universe, not because of it. Earth isn't typical, it's lucky. We're only at the beginning of this discovery era. Every year, new telescopes sharpen the picture, and every year, the picture gets stranger. The more clearly we see the universe, the less it resembles our imagination. And that's the most unsettling truth of all. Okay, here you are, in the middle of the ocean. It's endless, but you can't see it, because there's a thick fog all around you. Dense clouds hide the huge but dim sun. Is it day or night? You don't know. There's only a gray haze around you. You're alone. Even if you try to swim down, after several hours, you still won't be able to see the bottom of the ocean. And that's a typical water planet for you. I know, sounded kind of dark, but it's not that bad. These water worlds are more interesting than they may seem, so let's take a look at them. The ocean planet is a planet that consists, as you might have guessed, mainly of water, ice, and maybe some rocks. Think of the Earth's oceans. Its horrifying depths, the Mariana Trench, and all that. And now, can you guess how much space all the water on Earth takes up? 0.025%, exactly. Now, just try to imagine a world of 40 to 60% water. If you dive in there, the depth can exceed 60 miles. Compared to that, the 6-mile depth of our Mariana Trench sounds like nothing. And yeah, the pressure there will be enormous. It can reach up to 20,000 Earth atmospheres. Very crushing. Now, it may sound scary, but it still would be great to find out more about these planets. Fortunately, according to scientists' calculations, there may be a lot of such planets in our galaxy alone. Well, you don't have to go far. You can find these water guys even in our solar system. Not planets, of course, but moons. Jupiter has Ganymede and Callisto, and Saturn has Titan and Enceladus. The ocean can reach up to 30% of the mass of these moons, although it isn't clear whether these oceans are covered with a thick crust of ice. But we've discovered quite a few full-fledged ocean planets. This is because the conditions in which these planets may exist are very specific. For example, this planet should be somewhere 6 to 8 times larger than the Earth. If it's smaller, it'll have a rocky surface. But if it's bigger, it'll turn into a gas giant. At the same time, it must be in the habitable zone of its star. A little further, and the planet immediately turns into an icy giant or a cold super-Earth. So yeah, these guys are very picky. We first started exploring these planets back in the 1970s. However, since then, we've found only a couple of them, but they're still very interesting. The first planet is Gliese 1214b. It was the very first ocean planet that we discovered. Initially, the scientists noticed only a small dim dot. This dot turned out to be the red dwarf star Gliese 1214, an unremarkable, completely ordinary star that's 5 times smaller than our Sun and 300 times dimmer. Scientists wouldn't worry about it at all, but back in 2009, they noticed that this star had one single planet, and this planet turned out to be quite strange. This super-Earth was 2.5 times bigger than our Earth and 6.5 times heavier, but at the same time, it had a very, very small density and about the same gravity as our planet. In other words, there were almost no rocks and metals on it, but it wasn't a gas giant either. So there was only one option left. It was covered in water and ice, and that's how we discovered the first ocean planet. Well, actually, we can only assume that it consists of water. That's what the mathematical calculations say. In reality, this planet is quite confusing. It's difficult to explore, and so far, scientists haven't been able to find anything there. No hydrogen, no helium, no water, nada. That's because the outer layer of the atmosphere of this planet is very dense, and it perfectly hides its composition. But even so, it's probably a water world. Gliese 1214b is very close to its star. It's only 0.014 astronomical units away, which is less than the distance between the Moon and us. The year there lasts about 36 hours, and the temperatures, to put it mildly, are just wild. Scientists suggest that the average temperature there can reach 250 to 535 degrees Fahrenheit. Woo, that's hot. Remember the creepy description from the beginning? Well, actually, spending time on Gliese 1214b would be a little different, more like swimming in a steam boiler. Because of such gigantic temperatures, the ocean on the surface will be constantly in a state close to boiling without actually reaching it. So, imagine that you're descending to the surface of this planet, flying through clouds of steam, and then you suddenly find yourself in the water. What? But when did it happen? Well, that's because the boundary between steam and water on Gliese 1214b will be very blurred. Of course, you won't be able to swim to the bottom of this ocean, but most likely, this bottom is covered with a very thick layer of so-called hot ice. It's like regular ice, but it doesn't really care about the laws of physics, so it just doesn't melt even at gigantic temperatures. And the thickness of this ice can reach as much as 3,000 miles. So that's it for the creepy Gliese 1214b, and not an Airbnb in sight. Now, although we can't 100% guarantee that it's a water world, we still have another candidate for this position. A newly discovered planet called TOI 1452b. This planet, located in the Dragon constellation, is almost 100 light-years away from us. It was discovered using the TESS telescope by a group of researchers from the University of Montreal. This planet also belongs to the class of super-Earths. It's 7 times larger than our planet, but 48 times heavier. Again, all this is at a very low density. Because of this, scientists have suggested that almost the entire planet consists of a giant ocean. Here, we were a little luckier. This world won't be just a giant puddle in some thick ice. On this planet, there's probably a rocky surface deep under the water, just like in a typical ocean. Don't get too excited though, this ocean will certainly be very different from what we're used to. TOI 1452b also orbits a small red dwarf, and not even one, but 2 at once. At the same time, if the previous planet was close to its sun, then this one, on the contrary, is very, very far away. It's 2.5 times farther from its stars than Pluto is from the sun, and it moves at great speed. A year there lasts only 11 days. But we still don't know many things about this planet. We'll probably get some new information when scientists observe it from the James Webb Telescope. Well, that's it. Wait, did you expect something else? All right, I know the question that bothers you the most. Can there be life? Well, this is a difficult question. We all know that water means life, and besides, these planets are in the habitable zones of their stars. So, potentially, yes, there might be life. Not some full-fledged civilizations, of course, but bacteria, fish, and some creepy giant monsters. I mean, why not? However, this is very unlikely. Water alone isn't enough to create life, even though it's very important. There should also be some microelements and some minerals. And unfortunately, for most water planets, the composition will only consist of water and very thick ice. There won't be any minerals there. But don't give up. There's still some probability. First of all, there are meteorites and comets. They can bring the necessary minerals to the planet. The more often they crash into it, the higher the probability that they'll bring something like this into the ocean and thus create life. Secondly, TOI 1452b actually has these minerals. Yes, we don't know how deep the rocky bottom is located there. But if it exists, then surely something could have originated there. Let's hope that new research with powerful telescopes will allow us to find out the truth. And who knows? Maybe one day we'll be able to visit such a planet ourselves. The hunt for interesting exoplanets and life forms somewhere out there in the vast expanse of the universe keeps going. No stopping here. We're basically searching for a second Earth, a planet that's similar to our home, and where we could finally find some space friends. Hey, we're not picky. Any form of life is fine, even some bacteria-sized organisms. And this search has mostly been going on in the habitable zone around other stars. We call this the Goldilocks zone. That's a region where conditions are barely just right for liquid water to exist, whether we're talking about the surface of a planet or a moon. The hotter the star, the more space we get to explore, because its habitable zone spreads far away. And in terms of endless space that we yet know so little about, that's a lot of work. That's why we're fans of red dwarfs. There are hundreds of billions of stars in our galaxy, and probably around 80% of them are red dwarfs. These tiny stars are much cooler than our Sun. It means that their habitable zones are much smaller and closer to the star, so we know better where to look for planets. They're circling around their central star, and at some point, bingo, there it is. They pass in front of it and block out some of its light. The Kepler Space Telescope has already helped us find thousands of planets using this method, and most of them are orbiting around red dwarfs. Some of these planets are similar in size to Earth, and many of them could have nearly 25 times more water than our entire planet. Let's move to these planets scientists discovered, though. I want to show you something special. So, you've heard of super-Earths, right? More massive than Earth, lighter than Neptune, can be made of rock, gas, or a mix of both. Some of them have thick atmospheres, while others have thin or no atmospheres at all. You may also have stumbled upon mini Neptunes by now, too. They're almost as big as Neptune, and unlike normal gas giants, they have solid cores. That way, they can support a dense atmosphere with water and some other chemicals necessary for life. There's also hot Jupiters. Those are pretty cool, but only if they're far away from us. You know that one annoying and unpredictable neighbor you can never get rid of or figure out what they're going to do? Yeah, that would be a hot Jupiter, with strong gravity that can destabilize the orbits of smaller planets or other space bodies in the system. If we had such a neighbor, there would be more comets and asteroids hitting our surface. Luckily, our Jupiter's a good and peaceful neighbor that minds his own business, at least for now. But let's leave all these and many other planets out there alone now. Imagine traveling around in your spaceship and coming across a giant eyeball just floating there in the darkness of space and staring at the central star of that solar system. It's not a monster. Hopefully, space friends we'll make in the future won't look that big and scary, so it won't blink or turn towards you as you come closer. It's actually a planet. A little bit bizarre, but still very cool. And yup, you guessed it right, we call such eyeball planets. Now, eyeball planets are surprisingly common. Plus, some normal planets can potentially turn into them too. Eyeball planets form when matter and dust accumulates around a star and gradually turns into a solid object. It starts spinning, and over time, the gravity of the star pulls on the planet and slows its rotation until it becomes tidally locked. That means one hemisphere always faces the star, while the other is in darkness all the time. Now we have a good example of this phenomenon near us, too. Our moon makes a circle around Earth once a month. It takes the same amount of time to turn a single time on its axis. That way, we actually always see the same face of the moon. Who knows, maybe the other side is even prettier, if you like craters and stuff. So one of the most interesting things about eyeball planets is their appearance. If they had water on their surface, the side facing the star would have clear, bright blue oceans, the ones we'd want to visit if we ever got a chance to go on an interstellar vacation. And the other side would be more for adventurers who like harsh and challenging surroundings. Since it's in constant darkness, it would most likely be very cold and covered in ice. We've discovered so many planets outside of our solar system in the last 30 years. Super-Earths are, of course, especially interesting. It seems that many of them are not that pleasant, since they're pretty hazy and cloudy. It means it's harder to spot any life there. But some scientists still think they're promising spots when it comes to finding life beyond our solar system. Eyeball super-Earths would be a good start. These planets are probably covered in large oceans. On the cold half, where the eternal night reigns, you'd experience Arctic conditions. I feel cold just looking at this. But the day side is my jam. Plus, it sounds promising when it comes to finding life. With all that sunlight, oceans, and stuff. One of the good examples where scientists are looking for life is an eyeball super-Earth that lies in a habitable zone of the closest star to our solar system, called Proxima b. Its day side could even have conditions and an atmosphere to support some form of life. There could be a large deep ocean covering its surface. It could be really salty, but some forms of life could still survive there. Check out the Dead Sea on Earth. It's extremely salty, but some bacteria have still evolved to live there. And they're probably doing well, having their own world and all that. It's not crowded because there are no animals there. Fish that accidentally end up in the Dead Sea won't survive there for long. So, similarly, it's possible that bacteria or some other forms of life could exist in this potentially very salty ocean on Proxima b as well. But the open ocean on Proxima b could be tricky. On the dark side of the planet, the ocean could freeze, and sea ice could drift into warmer waters. That way, the ocean would cool, and more of it would freeze, even on the sunny side. The only way to prevent this global freeze-over would be an atmosphere with a lot of greenhouse gases like carbon dioxide. This kind of atmosphere would trap the heat from the planet's surface and wouldn't allow it to escape into space, like what happens with Venus, the hottest planet in our solar system. Without an atmosphere with greenhouse gases, the surface of Proxima b would be much colder, so it's possible that the planet would completely freeze over. The opposite scenario could also be possible. Warmer waters could serve as a transporter of heat from warm to cold regions. We don't know much about the conditions on the planet yet, so Proxima b could range from a frozen wasteland to a hot, hazy world, depending on many factors. So yeah, an eyeball planet within the habitable zone sounds promising, but its surface can still wildly range from a frozen desert to an endless ocean. Some experts believe that drifting sea ice might cool many exoplanets out there, and they can't turn into eyeball worlds. Instead, many just become sad, dark snowballs, completely covered in ice. A cool spot to spend your interstellar winter holidays, but not a place where you'd hope to find life, unfortunately. Some studies show that even Earth may have gone through some snowball stages many times in history. One of those happened around 2.2 billion years ago. I wasn't around. While the other one hit the planet 630 million years ago. During these phases, all of our beautiful oceans were covered with snow and sea ice. Perhaps even the continents were just thick ice sheets, at least on the surface. Alright, enough with the freezy icy stuff. I need some hot chocolate. Earth. Home. The third blue rock from the Sun, the only known planet where life can thrive. We have around 78% nitrogen, 21% oxygen, and 1% argon, water vapor, and carbon dioxide, give or take. The perfect balance to support our respiration. The troposphere is the lowest and densest part of Earth's atmosphere, 5 to 9 miles thick. It's the part of the atmosphere that keeps changing our weather. For any life to exist, we would need this atmosphere and the same combination of gases to breathe. If all the planets in our solar system were combined to become a mega-Earth, then humans wouldn't have evolved the way we are today, and we'd have a very different planet. If we take the landscape of Mars, we'll only have solid land without large bodies of water. Earth is the only planet in our solar system with bodies of water. One of the first wonders to see will be Olympus Mons, the largest volcano in the solar system. It towers Mount Everest by a long shot at 78,000 feet above the ground. Velis Marineris is a group of canyons that make the Grand Canyon in the U.S. feel like a average one. This wonder stretches for almost 2,500 miles and goes more than 4 miles deep. On top of these epic terrains, there's plenty of other grand-scale locations on Mars that are way bigger than the ones on Earth. The planet might be as large as Jupiter. If the Earth were the size of a grape, then Jupiter would be the size of a basketball. We'd have the size of Jupiter and the rings of Saturn floating around us. The rings may seem like some large chunks of rock in the air, but they're actually ice particles and chunks of iced rocks. They range from the size of pebbles to car-sized ones. Saturn's rings are supported by the unique gravity in the region. With a lot of these ice rocks floating in the sky, there won't be much sunlight entering the planet, which means the planet will always be colder than usual. Not to mention the many moons it has. Our megaplanet could also have many moons circling above us, contributing to the tidal waves. Jupiter is known for the red spot, a place twice the size of Earth that has hurricane-like storms that have been going on for hundreds of years. The people of Mega-Earth will settle far away from it. Mercury is a planet but looks like the Moon due to all the craters lying around. That's because of many asteroids and comets striking it over billions of years. But the landscape here mainly consists of mountains, highlands, cliffs, and valleys. The Caloris Basin is almost 1,000 miles wide. They believe it was formed by a comet. The deserts on Earth are mainly hot and consist of dunes of sand, but they also have flat plains and small hills. The largest desert in the world is the whole Antarctic continent. Mercury has no atmosphere to trap any heat, so it gets really hot when the sun is facing it and freezing cold when the planet turns away from it. On this combined mega-Earth, the desert will most likely have a similar landscape to that of Mercury. The animals living here will probably be something like giant scorpions and desert snakes that soak in some sun during the day and go out hunting at night. But the soaring day temperatures would melt anyone walking. And even though Mercury is the closest planet to the Sun, it's not the hottest. Venus has temperatures of nearly 900 degrees Fahrenheit. Scientists believe that the lands here are flat because of the extreme temperatures, but it's not all flat, with some volcanoes and highland areas. We can probably find this terrain and climate near the equator, since it's always hot there. Humans can't live there unless they build special domes to sustain life. But since the planet is now huge, not all its territory needs to be populated. Some areas will have the proper atmosphere for breathing, but some places might not have such luxuries. Over at the poles, the climate will most likely mimic Pluto's, even though it's not technically a planet anymore. In 2006, they officially declared it a dwarf planet, and it's even smaller than the Moon. There's not much known about this little mini floating rock, except that it's composed of around 70% rock and 30% ice. Scientists believe that a part of its surface is covered in frozen nitrogen, solid methane, and carbon dioxide. Since the megaplanet is huge, gravity might be quite strong here. Jupiter's gravity is enough to double your weight. Humans will most likely be really tall and mega-sized to match the big planet. Even the oceans will be huge. Our oceans will look like little lakes compared to what Mega-Earth has in store for us. Humans need something close to 24 hours in a single day. Our bodies adjusted to it quite well, but it wouldn't affect us too much if the day had a few extra hours or a few hours less. We can't live on any other planet without wearing the proper gear. We wouldn't last more than a few seconds in places like Jupiter, Neptune, and Saturn. It's possible to last as long as you can hold your breath on Mars. The atmosphere is thin and the gravity is similar to ours, but you might freeze. Even though it's a red planet, It's actually very cold and has ice caps in the poles covered with carbon dioxide. The same's true for Mercury. You can only last there as long as you can hold your breath and be in the sweet spot between the sunrise and the sunset. Ancient civilizations wouldn't have been as diverse as they were on Earth, since the extreme terrains and conditions wouldn't have allowed for discovery and trading. But eventually, as humans developed special technologies for certain areas, different cultures would emerge. Many animals would also evolve in specific and unique ways, but because of the planet's enormous size, isolation, and being on top of the food chain would let certain animals be around since the beginning of the planet without evolving. So it's possible that this mega-Earth might have ancient dinosaurs roaming around, and they'd be even bigger than the ones on Earth. And even though there's a high chance that some humans might be physically different than each other, there might even be more than one species of humans living on opposite ends of the planet. Because of the isolation, they evolved in their own ways according to their surroundings. Over the centuries, technological advancements would spread different cultures around, and we'd be more open to each other. Neanderthals and Homo sapiens once lived side by side and were considered as the two species of humans. Neanderthals were intelligent and used tools for hunting and drawing. Homo sapiens were survivors and wandered around to discover new land. There could be two dominant human species and other minor ones that live in certain areas on Mega-Earth. They'd be bigger, tougher, and faster than us. The ones who live by the trees would have elongated limbs to stretch out and swing from tree to tree. The ones that live in savannas will probably run really fast and have long legs for that. Countries and cities will be bigger than what we have on regular Earth. A country can be as big as Earth itself. The human population can reach tens of billions. Special transportation technology might be invented for people to travel from one continent to another. Covering those distances can take months or even years if using regular aircraft. High-speed trains that travel so fast over land and rocket-like planes going through the sky. Traveling through oceans will require extremely sturdy ships. Traveling through the Atlantic Ocean is already scary for many, so imagine going on a voyage across a body of water that's potentially 8 times the size of Earth. We're going to need a bigger boat. There'll be areas to avoid, like the red spot with its perpetual storms raging on, but the tourist industry might have some room for anyone who wants to see it. Living on such a huge planet is unlikely going to become a reality for most of us anytime soon, but scientists are already discussing moving to other planets to find a new home for humans. This planet, the one right here, shouldn't exist, but it does. A newly discovered planet rotates around a star that's much smaller and dimmer than our Sun. The planet, however, is enormous. Such a tiny star couldn't create it, so it's like finding an ostrich egg in a chicken coop. A team at Penn State built a special tool called the Habitable Zone Planet Finder. It's an instrument that's supposed to find planets around dim, cool stars. It's connected to a big telescope in Texas. The tool looks at the light from these stars, which is mostly in the near-infrared, beyond what our eyes can see. This gadget can spot changes in a star's speed caused by a planet. If the star movement slightly changes, that means there must be a gravitational pull nearby. Years ago, this technique helped find the first known exoplanet around a star like our Sun. Today, we've improved this method to make more precise measurements. Our main goal is to find Earth-like planets. They should be rocky and located in habitable zones, areas around stars where liquid water could exist. The Doppler technique isn't that great at finding Earth-like worlds yet, but works well for cool, dim stars. And that's how we discovered the impossible LHS 3154b. Planets usually form in disks made of gas and dust in space. Picture a flat, spinning cloud of tiny particles. These particles come together and stick to each other, creating a flat, rotating disk. Over time, these tiny bits combine to form a solid core. This is the starting point for a planet. Once the core is there, it attracts more dust and even gas like hydrogen and helium. But making a planet this way isn't easy. They need a lot of stuff, mass, and materials. This process is called core accretion. Stars are a huge help in that process. Usually, big stars have more gravity, so they can gather more stuff to form planets. But the star we discovered recently isn't very big. It's 9 times smaller than our Sun. A star this small shouldn't have a big enough disk to make a heavy planet. To do that, its disk should have been at least 10 times bigger. But this heavy planet, LHS 3154b, exists. Now, this mysterious planet is 13 times heavier than our Earth. It's similar in size to Neptune. It's about 50 light-years away from us in the Hercules constellation, which, in space terms, is very close. The planet is also super close to its star, completing 1 year in almost 4 days. This discovery is making scientists rethink their ideas about how planets and stars come into existence. There are new theories coming around. For example, a theory called gravitational instability. It says that, instead of the pieces coming together bit by bit, the material in the disk collapses all at once, directly creating a planet. But even with this theory, it's hard to explain how such a heavy planet could form without a really massive disk. It'll take us some time to figure out the truth. This isn't the first planet that makes us doubt our theories. Recently, scientists found another planet called Hala. This planet is orbiting a star called Baekdu, and just like the previous one, it shouldn't really exist. It's way too close to its star. Stars change a lot during their lives. Normally, when a star becomes big and prepares to leave this world, it's called the red giant stage. A star like that tends to destroy or push away any nearby planets, creating a huge mess. Hala rotates around a red giant, and it should have been swallowed or destroyed by the expanding star a long time ago. But it's still hanging there. Even though Baekdu has already started burning helium and shrunk to a smaller size than expected, Hala isn't bothered in the slightest. Scientists call Hala the Forbidden Planet. This discovery challenges what we thought about how planets survive near aging stars. It raises 2 theories. One suggests that Baekdu was once 2 stars, a white dwarf and a red giant. Hala orbited them both, and they merged before the red giant fully expanded. This allowed Hala to survive because the extra helium from the white dwarf prevented the red giant from growing too much. The second theory says that Hala formed from the debris created when the 2 stars merged. In this scenario, Hala would be a very young planet orbiting an elderly star. Astronomers plan to continue studying Hala and look for more planets like that. Another oddball, besides me, is called LTT 9779b. This one scares us too because it's too shiny. The planet reflects 80% of the light from its star. Regular mirrors reflect from 85 to almost 100% of light, which means that this mysterious planet should look like a rough mirror, with aluminum or silver-like reflections. This is another Neptune-sized planet. It's located 268 light-years from us and was discovered by NASA's TESS spacecraft. It completes a full rotation around its star in just 19 hours. It's so close to its star that it's scorching hot, reaching temperatures over 3,600 degrees Fahrenheit. Normally, planets this close lose their atmosphere and turn into bare rocks. But this one breaks the rules again. Now this time, we know the secret of its survival. It's because of the planet's shiny metallic clouds, which are made of glass and titanium salt. These clouds rain titanium onto its hot surface. They also reflect a lot of the light, preventing the planet from getting too hot and losing its atmosphere. It's like having a mirror shield. This planet's size also surprised scientists. It's way bigger than Earth. Other planets this close to their stars are either much bigger gas giants or small rocky planets. This planet is a smaller gas giant, and scientists didn't expect it to exist so close to its star. This is the shiniest planet ever found, even shinier than Venus. But despite its cool appearance, it's probably not a friendly place for life because of its extreme temperatures and strange metallic rain. And our final rule breaker is a planet called WASP 107b. Scientists discovered it using the James Webb Space Telescope. It's located around 208 light-years from us in the Virgo constellation. It's also fast and completes an orbit around its star in just 6 days. This is a super Neptune exoplanet. It's similar to Jupiter in some ways, including the same size and scorching hot temperatures. But the main difference is that it's much lighter, weaker, and less dense. This is the least dense planet we've discovered so far. After researching some more, we also found that it has a tail. The helium on the planet extends beyond the transit egress. The planet is slowly losing its atmosphere due to extreme ultraviolet radiation from the star. This creates a comet-like tail. So, it looks like a fluffy comet. But that was just the beginning. The planet's low density, or fluffiness, allowed astronomers to study its atmosphere in detail. They found some surprising things, like water vapor and clouds made of fine silicate particles, which are like really fine-grained sand. The planet's host star doesn't emit a lot of high-energy light. But since WASP 107b is so loose, the light can penetrate deep into its atmosphere. This creates sulfur dioxide that smell when you light a match. In other words, it's a fluffy planet that rains sand and smells like matches. The researchers think the sand clouds in the atmosphere form in a similar way to clouds on Earth. They just have droplets of sand instead of water. These sand droplets condense, fall, turn into silicate vapor in hot layers within the planet, and then rise again to form clouds once more. And, once again, this planet couldn't have formed in its current spot. Astronomers say that it likely moved closer to its star from a birth orbit because it was attracted by some heavier neighbor. It also follows a retrograde orbit, meaning it orbits in the opposite direction to its star's rotation. All these discoveries are changing how we understand planets and their atmospheres, giving us new insights into the mysteries of our own solar system.
Take that giant space knife. Yes, you. It's time to visit the sun and check what's inside. First, you're slicing through the corona, aka the sun's wild hair. It's the sun's super thin atmosphere, but don't let it trick you. It's blazing at 3.5 million degrees Fahrenheit. While cutting through it, you see plasma threads whipping around like solar spaghetti. You reach the photosphere, the sun's skin. It's only about 300 miles thick, but it's super bright and sizzling at 10,000 degrees Fahrenheit. Looks like it's covered in little fiery waffles. They're called granules, and they're each about 600 miles wide. Then comes the convective zone, where hot plasma is floating up in bubbly chunks. Next, the radiative zone. This part's like molasses made of light. It takes 170,000 years for energy to crawl through here. Finally, you start cutting into the core, and instant heat wave. It's like the sun's pressure cooker. Gravity's smashing hydrogen atoms together to make helium, and it's cooking at 27 million degrees Fahrenheit. Now, you're gonna need a smaller knife, since the next candidate, Mercury, is the smallest of the inner planets, only about 3,000 miles wide. When you cut through its thin atmosphere, you see little hydrogen and helium atoms escaping inside tiny invisible balloons popping away into space. Next, the crust. Together with mantle, it's only about 250 miles thick. As our giant knife passes through, you see hard rock flakes falling off, cracking under the pressure. Mercury has a gooey outer metal core. Slice carefully, or you'll spill some liquid metal lava. Finally, you hit the inner core. Mercury has a massive metal heart. Around 85% of the whole planet is just iron and metal. It's basically a giant metal meatball. Cut through it and watch molten iron juice oozing out like spicy hot sauce. You're now approaching Venus, the hottest planet out there. We're talking about average temps of 870 degrees Fahrenheit. Hot enough to melt lead. You slice through the atmosphere and it's crazy. Thick clouds of sulfuric acid swirling everywhere, and it's mostly carbon dioxide. Like a bad greenhouse on steroids. Pressure there is insane, like being 3,000 feet underwater on Earth. Thick yellowish clouds are puffing around the blade, sizzling like acid rain. Then comes the crust. A thin shell of mostly basalt, just 6 to 18 miles thick. It's like cutting through a crispy rock pizza crust, thin but tough. Cut deeper and you're in the molten rock mantle, about 1,800 miles thick. You can see the rocky magma wiggle and ooze. Finally, you hit the metal core, about 1,900 miles wide. That's like slicing a chunk almost the distance from Chicago to LA. There's a giant iron ball inside, all molten and heavy. Alright, time to cut through Earth. Now you might need a whole chainsaw to deal with this rocky planet. First, your chainsaw bites into the crust. It's thin, only about 1% of Earth's volume. You hear a sharp crack as the brittle rocks snap and crumble. Dust and tiny minerals puff out, and the crust breaks into chunks, like snapping a hard cookie. Next, the blade presses deeper into the mantle. Thick, tough rock that's solid but kinda squishy if you wait long enough. As you slice, the hot rock kind of oozes and bubbles, leaving a warm trail along the blade. Keep going, and you hit the outer core, a huge sea of molten metal. Suddenly, the knife slides through thick, glowing liquid iron and nickel, like cutting through a giant cosmic lava lamp. Finally, you smash into the inner core. Solid metal this time, like a glowing steel marble buried deep inside. The blade scrapes across its dense iron-nickel surface with a harsh grind. It's blindingly bright and insanely hot here, hotter than the surface of the sun, and the pressure would squash any real blade flat. Put the chainsaw aside. For the next planet, you'll need something of a more modest size. You're zooming over to Mars, the last of the rocky inner planets. The knife breaks through Mars's crust. It's thin and solid, made of volcanic basalt rock. As the blade cuts in, fine reddish dust, like cosmic talcum powder, puffs up, drifting everywhere. The crust doesn't crack into big plates like Earth's. It's one big solid shell. Next up, the mantle. Think of it like thick, soft, rocky toothpaste. Not totally solid, but not mushy either. The knife slides through it with some resistance, and you see glowing silicate goo in red and orange shades, swirling around the blade. The mantle is thinner than Earth's, only about 800 to 1,100 miles thick, so you don't have to wait long to get to the juicy middle. Finally, you hit the core, a metal mix of iron, nickel, and sulfur. Mars's core is molten, but it's cooler and more chill than Earth's. In any case, it's easy to cut through, no effort needed. We're coming close to Jupiter, the biggest dude in the solar system. Jupiter is a gas giant, basically a giant balloon filled with crazy stuff. As you cut it, you don't hit solid ground at first. Instead, it's all thick, swirling gas, mostly hydrogen, around 90%, and helium. It must feel like slicing into super thick whipped cream that never ends. As you go deeper, the gas gets so squished that it turns into a thick liquid. The blade pushes through layers of swirling storms and colorful clouds that whirl around. Keep going, and the gas becomes metallic hydrogen. The knife slices through a glowing, electrified liquid that crackles around the blade, like you're cutting through electric jelly. Finally, somewhere way deep inside, you reach the core, which might be a molten hot ball of liquid or a giant rock heavier than 14 Earths. Nobody's totally sure. But if you could slice through it, the core would be hotter than 43,000 degrees Fahrenheit. A regular blade would melt instantly or be crushed from all that pressure. It would be pretty tricky to cut open the next planet, not because it's too hard or rocky, but because there's basically nothing to cut through. In Saturn's outer layer, your knife hits thick, swirling gases, mostly hydrogen and helium, but with some funky extras like methane, ammonia, and water vapor. As you cut, a smoggy orange haze puffs out. That's all the sulfur giving Saturn its groovy look. The atmosphere and surface blend together. No hard ground here. As the blade digs deeper, the gas gets squeezed tighter and tighter. Hydrogen starts turning into thick liquid, and your knife leaves trails through this gooey, glowing layer. Keep going down, and suddenly, the liquid gas turns into metallic hydrogen, shiny and electric, crackling around your blade like a sci-fi lightsaber. Deep inside, you might hit a rocky core, but no guarantees. It might even be liquid rock, glowing and swirling beneath all that gas. Next, we're gonna split open an ice giant, Uranus. Its atmosphere has enough methane to give the planet that cool blue-green glow. As your blade moves, a faint icy mist sprays off. It's like slicing through a cold, foggy cloud. Next, you slice into the ice mantle, which makes up about 80% of the planet. But don't think frozen popsicles. This is a thick, hot, gooey soup of water, ammonia, and methane ice. The blade pushes through this dense, slushy ocean with little bubbles and steam escaping as you go. Then, bam! Blade hits the rocky core, small and dense, half as heavy as Earth. It's cooler than most cores, about 9,000 degrees Fahrenheit, which is still crazy hot. The blade scrapes over solid rock with sparks flying off like cutting metal in a cold workshop. Neptune's also crazy cold, but cutting it feels different. When cut, it whips clouds of frozen methane flying past at 1,200 miles per hour. It feels like slicing through a freezing, super windy blizzard. Next, you plunge into the mantle, a thick, boiling hot soup of liquid water, methane, and ammonia. The knife pushes through this dense stew with bubbles popping and steam hissing. Temperatures here range from 3,000 to 8,500 degrees Fahrenheit. Even deeper, the blade hits Neptune's solid core, mostly iron, metals, and silicates. The blade scrapes along this tough metal center, sparks flying like you're welding the heart of the planet. Now, comment below, which planet was the most satisfying to cut through?
You take a giant straw and begin to inflate Saturn. It's getting bigger and bigger and bigger. That's enough. Now let's add some giant rings. That's it. This is Super Saturn, also called Saturn on steroids. It's a real object that scientists discovered in 2012, a planet named J1407b. And astronomers are still not sure what it really is. It could be a gas giant, like Jupiter or Saturn in our solar system. Then there would be no solid surface there. And if you wanted to set foot on that planet, you just fall through it, all the way to the core. But it could also be a brown dwarf. That's something between a large planet and a full-fledged star. Such objects have to be heavy enough to start thermonuclear reactions, like those going on inside stars. But the power of these reactions is too weak for brown dwarfs to glow and emit heat. To imagine the size and weight of J1407b, let's look at our Earth. If you put our planet on a scale, it'll show 6 and another 21 zeros tons. Our planet is also about 7,900 miles across. Now, that's Jupiter, the largest planet in our solar system. Its diameter is 11 times as great as that of Earth. It's also 318 times heavier. If Jupiter were a bucket, you could put 1,321 Earths in it. And this is the hero of the day, Super Saturn. It's almost 20 times as large as Jupiter. To balance the scales, you need to put 6,360 Earths on the other side. The planet's rings are so wide that if they were in the solar system, they would take up more than half the space between the Sun and Earth. And if Super Saturn switched places with the original Saturn, you'd see those rings with the unaided eye. They would be larger than a full moon. Presumably, these rings appeared in the same way as the ones around our Saturn. One theory says they're the remains of a moon that was once there. Its orbit was unstable, and over time, the moon got torn apart by the tidal forces of the huge planet it orbited. Small pieces of the former moon took their places in the giant's orbit. They collided with one another, like in a blender. After some time, everything that was left was basically particles of dust and ice moving around the colossal planet. Another theory suggests that the rings appeared after the moon collided with an asteroid or another moon. Then the gravitational blender did its job and turned the moon's debris into the rings. Some scientists think the rings formed at around the same time as the planet itself. So they're just the remains of the planetary nebula, which is a cloud of gas, space debris, and dust. Later, it probably shrunk and solidified to form a planet. We can only guess where Super Saturn got its rings from, but scientists say their mass is 80% of that of Earth. It may mean that the moon that used to orbit J1407b was about the same size as our planet. There's a little gap in the middle of these rings. Scientists think Super Saturn's moon might be there. If this is the case, it should be about the size of Mars. If scientists are right and Super Saturn is actually a brown dwarf, then this is an incredible discovery. Scientists will be able to watch it age. Supposedly, brown dwarfs lose their energy and shrink, fading in the process. And when a brown dwarf exhausts all its energy, it turns into a black dwarf. It's easy to confuse it with a black hole. People haven't discovered black dwarfs anywhere in the universe yet, because they take trillions and quadrillions of years to form. Our universe is too young, and none of the stars, even those that appeared when the universe was born, have had time to become black dwarfs. One of the oldest objects in the universe is the white dwarf, with a pretty long name, WD0346+246. It's about 11 to 12 billion years old and half as cold as our sun, and it's still cooling. It would need around 10 plus another 15 zeros years to turn into a black dwarf. For comparison, the universe is 1.4 and 10 zeros years old. Scientists believe that a black dwarf will exist for about 10 plus 25 zeros years, feeding on dark matter. After that, its protons, the smallest particles of matter, will begin to decay. And then, the black dwarf will simply evaporate. That will take another 10 plus 49 zeros years. But if the protons remain intact, a much more interesting scenario will await the black dwarf. In another 10 and 1500 zeros years, the black dwarf will become an iron star. It's essentially just a cannonball in space. The iron sphere will exist billions of times longer than our entire universe has existed, until it suddenly turns into a black hole. So, the process of the formation of a black dwarf is extremely long. It'd take a regular star an insane amount of time to age that much. But Super Saturn, if it is a brown dwarf, may be much closer to this state. Saturn on steroids is not the only strange planet in our universe. This is Gliese 436b. It's been detected using the transit method. A transit happens when a planet moves between its host star and an observer. It looks similar to a lunar eclipse. This planet is 4 times the size of Earth and 22 times as heavy. That's almost like Neptune. It's an exotic water world. The water there is solid, but it's not ice. It has a temperature of about 520 degrees Fahrenheit. The water in your pot turns into steam at 212 degrees Fahrenheit. But on Gliese 436b, the liquid remains solid because of the extreme pressure on the planet. Scientists have also discovered that the planet's atmosphere is evaporating into outer space. That's why there's a giant circular cloud around it. It's constantly moving in its orbit, giving the planet a long tail that looks like that of a comet. Cancri E holds incredible riches worth more than all the money on Earth. There are diamonds scattered all over the planet. Air is almost twice as high as the temperature of a burning fire. And since the host star is rich in carbon, the planet contains plenty of this element too. The intense pressure and temperatures help turn carbon into graphite and diamonds. Unfortunately, this planet is 40 light years away from our home, so it'd take about 730,000 years to get there on a regular rocket. Another planet rich in gems is HAT P7b. It's about 1,000 light years away from Earth. It's 60% as large and nearly twice as heavy as Jupiter. The planet is so close to its host star that it makes one revolution around it in just 2 Earth days. Because of such close proximity to the star, HAT P7b is almost as hot as a white dwarf. If you look at the night side of this planet, you'll see unusual clouds. Scientists believe that these clouds may be rich in corundum material. This is the very substance that forms rubies and sapphires, so it's likely to rain very expensive and beautiful gems there. WASP 12b is one of the darkest planets ever discovered. Only one of its sides faces its host star. The planet's surface is so dark that it eats up about 94% of all visible light, so it looks a lot like a black hole. The host star heats up the planet so much that the material there continuously evaporates. Then the star's strong gravity pulls this cloud toward itself, forming a disk. But TRES-2b is the champion. It's the darkest planet known to people. It absorbs 99% of the light coming from its star, which means it consumes more light than a piece of coal. 1% of the remaining light looks red as it gets reflected by this gas giant. From afar, this planet looks very evil. One of the oldest planets in the universe is PSR B1620-26b. It's about 12.7 billion years old. This means that it formed about 1 billion years after the Big Bang. The planet is so old that its two host stars have had time to evolve. One is a white dwarf. The other is a pulsar that makes almost 100 revolutions per second. Sunrises on this planet must be stunning. Right now, this star system is moving toward a dense cluster of stars. This is likely to lead to a stellar collision, so the fate of this planet is unknown. Kepler 438b is one of the most Earth-like planets. It's only 12% larger and is in the habitable zone of its host star. Not too close and not too far away. It's a sweet spot where water doesn't evaporate because of the heat and doesn't turn into ice because of the cold. This planet might host life on its surface. In the future, it may also become a new home for humanity, but it would take people about 470 years to get to this planet, even if we traveled at the speed of light, which is impossible due to the laws of physics.
Uranus is an enigmatic giant that has puzzled astronomers for centuries. But what sets this gas giant apart from the others is its strange tilt. While most planets spin on an axis that is perpendicular to their orbit, Uranus takes a wild spin in a different direction. But why does it look like this? How did the planet turn out to be lying on its side? And what would we see if we visited the surface of such a planet? Let's find out. Uranus, the seventh planet from the Sun, is a cosmic oddball and source of many jokes. It's one of the gas giants in our solar system, along with Jupiter, Saturn, and Neptune. It's also the third largest planet in our solar system, with a diameter of about 31,000 miles. And one of its many oddities is a weird rotation on its side. Not all planets in our solar system are aligned in a straight line. While most planets in our solar system have an axial tilt of less than 30 degrees, Uranus is tilted at an angle of almost 98 degrees. It's like that one friend who always has to be different, even if it means standing on their head to prove a point. So its north and south poles are facing east and west. It's like the planet got lazy and just rolled over one day, deciding to take a nap. And why is Uranus so tilted, you ask? Scientists once thought this was due to some kind of collision. They thought that something gigantic crashed into Uranus, something like what happened to our Earth. A dwarf planet crashed into it, the Earth tilted slightly, and the Moon was born from the remnants of the collision. But this theory had a problem. In the early universe, there were a bunch of asteroids, dwarf planets, and other large objects. And if this is so, then why is only Uranus tilted? All sorts of guys have crashed into other planets too, but they don't have such features. But recently, scientists have published a new study, and now scientists think that the culprit might be a long-lost moon that wandered away. Back in the days of the early solar system, the giant planets partied much closer together and way closer to the sun. But, as we all know, parties can get out of hand. Something caused Uranus and Neptune to migrate the farthest, like they were trying to get away from the sun's strict supervision. Each giant planet had a collection of moons, but they were constantly getting shuffled around during all this migration madness. Some planets lost moons, while others gained new ones. Uranus could have been born with a massive moon, or quickly captured one. And if that moon was big enough, it could have started playing games with Uranus's spin. This moon pulled on Uranus with its gravity, making the wobbling even worse. As time went on, it made Uranus tilt more and more. Eventually, it crashed into the planet, locking it into its current tilt. While the theory is pretty sound, based on computer models, we'll have to wait until at least 2030. That's when China plans to launch the Tianwen-4 spacecraft to take a closer look at Uranus and study it more. Who knows what other crazy space secrets we'll uncover next? Until then, we can all have a good laugh about the lazy, rebel planet that just can't seem to stand up straight. Such a funny and unique feature makes you wonder, what exactly would we see if we were standing on this planet? How would its strange tilt affect the view from its surface? Let's see. If you were standing on the surface of Uranus, although it doesn't really have a surface, it's more like a gas atmosphere, you'd enjoy a cool view. You'd see the sun rise in the east, just like on Earth, but then it would keep going around the sky in a tilted path, like a lazy spiral. About the sunset, though, I hope you have some patience, because it would take 42 years for the sun to complete one full circle around Uranus's sky. That's a really long time to wait before finally going to bed. But speaking of the sky, it would be a beautiful sight to behold. Uranus is known for its stunning, unique blue-green color. It's caused by the methane gas in its atmosphere. Methane absorbs red light, giving Uranus its cold hue. You'd also see some amazing clouds and storms swirling around the planet. But if you're looking for constellations, you're out of luck. The extreme tilt of Uranus means that its poles face towards the sun, so the stars would be all over the place in the sky. The constellations that are familiar to us would be unrecognizable from Uranus. Also, as the planet rotates, the position of the stars would change very often. For you sailors out there, good luck in navigation. But you could see its beautiful moons. Uranus has 27 known moons, with the largest being Titania, followed by Oberon, Umbriel, Ariel, and Miranda. These moons are thought to have formed from the same material that formed Uranus, and yes, the tilt affects them too. They orbit around the planet perpendicular to the planet's motion around the sun. And they aren't the only ones. Did you know that Uranus also has rings? Yeah, not only Saturn is so special. The rings are made up of ice particles, some as small as grains of sand, and others as large as several feet across. They're thin, narrow, and dark compared to Saturn, for example. They're actually so black that they almost don't reflect the light. That's why it's so difficult to see them from Earth. But if you were near the surface of Uranus, you might be able to see them in the sky. The only question is, would you even be able to focus on all these views? Because Uranus is extremely cold, and that will probably be the only thing you'd think about. We're talking about temperatures that can drop down to negative 350 degrees Fahrenheit. Brr, better pack some warm clothes for this trip. This is because it's so far from the sun, and its atmosphere is composed mainly of hydrogen and helium. And not only is Uranus the coldest planet in our solar system, but the winters there are long. Due to the extreme tilt, it has seasons that last for over 20 years. It's like the planet is stuck in a perpetual state of winter, which is both cool, pun intended, and kind of sad at the same time. And if that's not cold enough, Uranus is also known for its strong winds. In fact, they can blow up to 360 miles per hour. So you might want to hold on tight to something, or wear a windproof suit to avoid being blown away like a leaf. And finally, Uranus's magnetic field is also tilted at an angle of 59 degrees from the planet's axis of rotation. This creates some interesting effects. The most obvious one is beautiful auroras, which are similar to the northern and southern lights on Earth. On Uranus, however, the auroras are located near the planet's equator rather than at the poles. Isn't that cool? The result is a dazzling light show that would make even the most jaded space traveler stop and stare in wonder. But even though it sounds pretty awesome, it makes it more difficult for spacecraft to navigate around Uranus. The magnetic field creates a lopsided gravitational pull that can affect the trajectory of spacecraft. This makes exploring Uranus a bit more challenging, but maybe it will change in the future. All in all, standing on Uranus would be a chilly, wobbly, and breathtaking experience, and definitely not your average stroll in the park. Next time you look up at the night sky, think of this beautiful icy planet And remember that even in the vast expanse of space, there is always something new and